Good morning, good afternoon, good evening for some of you. Just want to take the time to thank everyone for joining the first of our Open Source Science for ESO Mission Data Processing Study workshop. This is an open workshop. However, I do ask if you did not receive a meeting invitation from Angela Clark, that you please take the time to register now. We will be sending out more correspondence about upcoming workshops and the proceedings from this meeting through our mailing list, and we're using the list of registrants for that. So I will, if I don't do it myself, someone else will post the registration link into the chat window. Some of you may have attended last week's Science Mission Directorate workshop. This is a follow-on to that workshop in more of a detailed sense. So again, thank you. And as was stated previously last week, your time and your commitment to the Open Science Data Initiatives is greatly appreciated. For those of you all who don't know me, I am Andy Mitchell. I am the project manager of ESDIS, the Earth Science Data and Information System project over at Goddard Space Flight Center. I'm the co-host of the data processing study along with another Andy, Andy Bingham, who you will meet later. And I think we're running up around 3 or 4 Andys that aren't in this meeting. So don't get confused if you see your name, different Andys in the chat. Next slide, please. So we will be using the WebEx virtual platform today and tomorrow. We ask that you put your first and last name in the display name and not use initials or nicknames. This way it will be easier for us to call on you if you're asking questions or if you provide any comments. We are recording this session. All the proceedings will be on our workshop website, open and available to the public. By chance, if you do happen to run into any technical issues, we do have technicians standing by. You can see them by their display name in the front. It says Tech, T-E-C-H, and you can send them a private chat message and they'll be sure to help you. And if you haven't noticed already, when you joined in the meeting, you were muted. So only the presenters and the members of the study teams have the ability to unmute themselves. By chance, if there is a guest that needs to say something, you can send a message through the chat and one of the moderators will try to get you unmuted. Next slide. So meeting logistics. So today we have Karen Yun, who will be emceeing. Tomorrow, Sarah Lupkin will be emceeing. They are going to be keeping us on track in terms of time. So don't take it personal if they give you a warning, any of the speakers a warning saying you have a couple minutes left in your allotted time slot. We will have question and answer periods after each session. We are prioritizing all of those questions right now towards the study architecture team. However, if there are other questions, we will try to get to them. But if we don't have the time, we do have note takers as well, and they will be capturing those notes, and we'll have the responses to those questions posted on the website along with our meeting notes. We do have allocated breaks throughout. And the next slide, I think, takes you to the actual website. Yep, there it is. So if you haven't had a chance yet, you can jot this URL down, or we'll also put this into the chat, and you can check back here for any updates on how the study is progressing throughout its term, and you'll hear more about that later from the other Andy. Next slide. We do have a full agenda today. The workshop is going to run 2 days. The workshop is also, the agenda is also available on that website, so I won't belabor this. Next slide. We are following a code of conduct here, but the most important principle, as we all know, is the first bullet on this. All participants are treated with respect and consideration, valuing a diversity of views and opinions. So by chance, if anything does occur where you feel like any of these rules are not being met, please send me an email. And I believe my email is on the next slide. Yes, you can send me a direct email at andrew.e.mitchell@nasa.gov, and I will be sure to address those matters personally. Next slide. Tomorrow we will have another full day, and I hope everyone who's here today will be able to participate in tomorrow's workshop. If not, you can take a look at the times of interest. Tomorrow is dedicated to our ESO missions, so we'll be hearing a lot from them tomorrow. Next slide. Yep, the next part of the agenda. So now I believe our first speaker will be Kevin Murphy, who is NASA's Chief Data Officer. Kevin, are you there?
I am. Hopefully, I've got my right camera on now.
I see you. Yep.
Okay, great. First, thank you very much, everybody, for coming today. I think that this is, the first of many discussions we'll have related to open science and the Earth System Observatory missions. As you all know, these are a very important set of missions for NASA, and your participation in the development of these activities is crucial to have a really good outcome. Before we get started into the specific ESO related activities, I'd like to mention kind of some of the work that's going on within the Science Mission Directorate related to open science. Back in December of 2019, Thomas Zurbuchen, the Associate Administrator for SMD, signed this strategy for data management and computing for groundbreaking science. And its vision really is to enable transformational open science through kind of the continuous evolution of our data systems and research programs and missions to support a lot more interaction with the open data that we produce from these large investments that we do. We've got 3 goals related to that strategy, and kind of my job, or one of my jobs, is to make sure that that works across all of SMD. But we'll be talking a lot about what we do within ESD, or the Earth Science Division, today. The first goal is develop and implement capabilities to enable open science, which seems pretty obvious. Steve Crawford will talk a lot about that in his conversation. Evolve our data systems and computing systems to support that type of work, and also work with the community to do it. Can I have the next slide, please? Now, you might be wondering what the Chief Science Data Officer is. This is a new position that was created back in, I guess, March of this year, and when I was selected for it. Since then, we've developed an office. This office is located within the Earth Science Division, but works both within the Earth Science Division, which is kind of the green or the green shaded areas, and across SMD related to advancing open science principles, and looking for commonalities across SMD related to computing and data, so that we can really leverage a lot of the things that are going on throughout. You can see that I have a couple of vacancies here. There's a deputy announcement that will be going out, and hopefully sometime later this calendar year, along with an operations position for the Earth Science Data System groups. Anyhow, we couldn't do this without a lot of people, and you can see a lot of them represented on here, and I just thank them very much. But if you see an announcement come out, please let us know if you're interested by filling out the USA Jobs announcements. Next slide, please. So first, I think it's useful to just kind of set the basis for how we define open science. And open science is really this collaborative culture enabled by technology that empowers data, information, and knowledge. And you know, it's really the entire research life cycle that we look at when we define open science. And you know, over the past couple years, maybe the past 10 or so years, as we've migrated into these cloud computing environments and enabled new techniques for collaboration, often with a lot of different platforms and other things out there, we're really getting to the point where we can do this with a lot less friction, right? Where we can share knowledge, where we can mine knowledge, where we can expand on knowledge or develop new data products in the instance of this, discussion much more easily. Next slide, please. However, there are a lot of definitions related to open science. And what I think a lot of them lack is the concept of actually making the scientific process open. And in this instance, we have initiated a new program called the Open Source Science Initiative, which I'll give a little bit of detail on in a minute. But really, this initiative builds on these concepts that were originally kind of explored and used within open source software development, and it applies them to the scientific process itself. Right. So start early with your openness, develop in the open, allow others to contribute in meaningful ways if their contributions are helpful, and by doing that together, we can increase how quickly we do it. Now, it's not to say that we haven't been doing components of openness, especially within the Earth Science Division, for many, many years or decades. Back in 1994, when the original open data policies or open data and information policies were kind of drafted, that was one of the first stepping stones that we're kind of building off with this. We've seen, incredible uptake of Earth science imagery. We've seen incredible participation globally related to the products that we produce. And this kind of open source science initiative and the work that we're doing specifically with ESO is kind of the next step in that evolution. Next slide, please. So what do the different meanings of open mean within open source science? Well, at its fundamental level, what we're trying to do is increasingly build trust in the scientific process. I think that we all have seen what's going on related to, information and how scientific results can be used or misused. And by making our science transparent, which means the scientific process and results are visible and understandable, by making it inclusive so that we work with participants throughout their professional careers, people that are outside of our standard groups, and that we provide opportunities for people that haven't traditionally had either the resources or capabilities to interact with our data and our science. We really excuse me, increase the umbrella of people that we can work with. Now, of course, that means that we need, can I go back one slide, please? That's, of course, we need to make these products accessible, which really accounts for like the FAIR principles of findable, accessible, interoperable, and reproducible for our tools, our software, and everything else. And the gold standard for science, obviously, is reproducibility. And that becomes increasingly difficult in situations where we use complex computer software and lots of data sources along with ancillary sources to create those products. If we can kind of nudge this in the right direction, we build trust, we increase the participation and accessibility of our science. Next slide, please. Other way. So at the SMD level, this open source science initiative really has 5 or 6 really major thrusts. One is Transform to Open Science, which is a 5-year program to increase understanding and adoption of open science principles and techniques. And we're working with professional organizations to identify or designate 2023 as a year of open science. We're continuing our investments in kind of open science infrastructural components that work across SMD. We're developing common data catalogs and the Astrophysics data system journal databases. We're expanding those to scientific content from other divisions. And we're really trying to work together to develop cloud prototypes and environments and analysis platforms. This really is not meant to do everything for all divisions. We have divisional investments in these areas too, including within Earth Science. We're trying to do this together, and we're aligning that. And you can kind of see the budget specifically for this cross SMD activity for the next 5 years, with about half of that actually going to this TOPS work, which is going to concentrate on really building the capacity within the community to have these discussions. Next slide, please. So here's a bit more detail on the TOPS effort, which is really, it's almost like a a project. We've got a 5-year project related to this, where we'll focus on public engagement. We have this TOPS GitHub where people can kind of interact with us. We're developing plans to engage with early and historically excluded communities. We're building capacity in how to develop cloud-ready data, how to develop learning resources, Jupyter Hub, so on and so forth. We're going to sponsor a number of summer schools, multi-day trainings, and massive online courses. And we're developing awards programs and other activities which are going to be vital to incentivize the community to move towards open science. Now, this is really, really critical, especially as we start looking at how this will work with ESO missions. Next slide, please. So before we get started into the specifics on ESO missions, I think it's important to discuss what we've been discussing with our international partners related to the expectations on how missions will work with an open science policy. First, all mission data, metadata, software databases, publications, and documentation shall be made available on a full, free, and open basis. Unrestricted basis, starting in phase B with no period of exclusive access. Excuse me. I think the only really big thing between this, big difference between this policy and previous policies is that we start this much earlier in the life cycle of the missions. We want to start this in phase B because we really believe that working with the communities, the potential communities, very early in the missions, that can contribute or benefit from the information that will ultimately be provided by these missions is incredibly important. And you'll see that 1 through 6 below here really kind of go into making that process of developing scientific products specifically transparent. Additionally, we have the no period of exclusive access. 21 years ago, when Terra launched, we had this concept of beta, provisional, and validated products. And we're resurrecting that for these, so that as we develop products, we can release them very early and allow people to interact with them with the correct caution labels. Second thing is, we're eating our own dog food in B here, which is, scientific workshops and meetings shall be open to broad participation and documented in public repositories. So a big part of making open science work is not doing open science behind closed doors. And I think that that's the most important component of B here, is that, to actually participate, you must be able to participate. So more specifically, software developed for missions, especially for the data products and the systems used to analyze information, shall be publicly accessible in version controlled platforms with permissive licenses. We can have specific conversations on what those types of licenses mean over the course of the next months. We're doing a big push to make sure that the manuscripts shall be published with open access licenses. This means that, if you have to pay a bit extra related to getting a permissive license for your articles, that's worth it. Because without that information, if there are paywalls to get the scientific results, that's not an open system. All mission data, calibration information, simulated products, supporting development and validation algorithms shall be made available without any conditions on use. We're also going to be assigning, in the parlance of earth science, the DACs in phase B. And that's going to really make sure that the scientific data, along with kind of building up those user communities that will use that information, the metadata, the software, and the publications, is done much earlier. So people will know where to go and how to get to those prototype or simulated products as they're developed and can participate in that discussion. Now we need to figure out ways to also acknowledge and incentivize the community to be open. And that means that we have to really recognize the contributions throughout teams, both within NASA and outside NASA and outside of our standard science teams, on their contributions, whether it be software or open documentation or scientific results, and attribute that information to them. But we need to jointly develop what those measures of success are. And finally, we're developing a kind of an umbrella of plans related to open source science. And we call this kind of the open source science plan. And this will embody things like the data management plans, open software development plans, open scientific collaboration plans, so on and so forth, along with the appropriate licenses for the data and the information that we're talking about. Next slide, please. So let me talk a little bit about the meeting objective before I hand it off to Steve Crawford, who will talk a lot about kind of the overarching SMD policies that are guiding this work. And I just showed you really a kind of a tailoring of those policies specifically meant for Earth science, although, you know, within our Chief Science Data Office, Science Data Office, we're really pushing for those types of requirements on other divisions as well. So let's get to the meeting objectives. So why are we having this study, and what's your kind of participation in it? Andy Bingham will talk to you about this in detail, but you know, accessing algorithms, workflows, computing, and analytic capabilities, it has really been a major barrier, right? Or even putting in new and innovative capabilities into existing systems has been a barrier for some time. And we need to open up how that works, right? As we move information into cloud environments, there's a greater opportunity for greater participation that, you know, is funded by NASA, but also kind of organically happens among the community to utilize these often very large taxpayer investments to develop scientific products which are highly valuable. So how do we make that work better? How do we bring in additional perspectives without, you know, derailing the train of missions? Of course, you know, we have to produce the products that the missions state they're going to produce. But how do we really open up the system so that we can allow for participation if people want to participate? That builds trust, like I said, transparency, so on and so forth with the goals. So the goals of this study are really to promote open science principles, to enable data system efficiencies, potentially by looking across the missions to see where we can do this together as opposed to separately. I imagine that most missions will be looking at cloud environments, cloud and open source environments to do this work. And we want to support generally Earth system science, including modeling activities. And finally, we want to expand the participation in the mission science beyond just the mission funded science teams. So in that blue box down there, you can kind of see what we're kind of looking at in terms of the architecture at this point. So thank you very much, and we'll move on to Steve.
All right. Hi, and thank you for having me join. My name is Steve Crawford. I'm the Science Data Officer, and I joined NASA about 1 year ago from Space Telescope Science Institute. And so I'm very happy to hear, and very interesting in having my background as an astronomer, very interesting to hear about the ESO and this upcoming study and listening to the details. But I wanted to give everyone and share with everyone information about the SMD Scientific Information Policy. And if you go to the next slide. As mentioned, the strategy for data management and computing for groundbreaking science had a number of different objectives along with the 3 goals. And the very first one was develop and implement a consistent open data and software policy tailored for SMD. And this is the work that we're trying to carry out here with SBD 41, the Scientific Information Policy. Next slide. And so NASA produces a lot of information from its scientific research activities, and this represents a significant public investment. NASA holds this information as a public trust to increase knowledge and serve the public good. And this includes publications, which are both our scientific and technical documents, our data, which is our scientific information that can be stored digitally, and software, our computer programs that have some scientific utility or produce a scientific result. Next slide.
And we want to have this information policy so we can actually support openly and widely sharing NASA research. The policy consolidates a wide range of applicable laws, guidance, and policies. It provides accessibility and a transparent policy for our program officers, scientists, and communities, and it helps support open science. And next slide. And so in developing the policy, we had some core values in the development, and we've been working on this for almost a year now, which was to maximize the openness of useful scientific information produced by NASA SMD funding, preserve the scientific information, support the community in accessing the information that they want, but also minimize the burden in complying with the policy. We don't want to actually just provide unfunded mandates. Next slide. And so what was released in September was SPD 41, the Scientific Information Policy. And this consolidates a wide range of different policies and is based on our current understanding of NASA and federal guidance and the aspects which are already applicable to our funding mechanisms, either ROSAs or Salmon announcements of opportunities. This applies to all SMD funded related activities producing scientific information, but the policy excludes restricted information such as ITAR or export controlled information. They're available at the website I posted at the chat, and so you can find the links to the website, which actually provides more information, along with a link to the policy, and I encourage everyone to take a look there. There's also a frequently asked questions to provide more information as well, and as part of the website. In addition, we'll also be providing more guidance, but we'll also be releasing a request for information on proposed additions to the information policy, which is based on new guidance and policies, but also on the how we can actually best implement the policy. Next slide. And just to give you some highlights, as mentioned, we want to make sure all SMD-funded publications shall be made publicly accessible. Our data shall be made publicly available without fee or restriction of use. Our software should be released as open source software, and our SMD-funded activities should have a data management plan that describes how these actually should be handled. Next slide. And especially for missions, some of the highlights include full and open sharing of the information produced by NASA SMD missions. This includes the observations, calibrations, coefficients, documentation, software, algorithms, technical reports, and any ancillary information or work product related to the mission. And this is both so scientists have all the information that they need, but also so that we can actually build the next generation of missions to build on what's happened in the past and the knowledge and techniques that are developed. There will also be no exclusive access to mission data. We want to make sure that it's actually made available as quickly as possible. Next slide. As there are also aspects of research where we do want to make the underlying research for our publications publicly available, and we also want to make sure our software is made available so our research is reproducible. Next slide. And so since we actually released SPD 41, there has been additional and new guidance, since 2015, when the NASA policy for open access to research came out, there have been a range of new proposed laws like the Open Data Act, recommendations, for example, the open source software policy options for Earth and space science from the national academies, and also additional federal guidance and best practices developed in the community. And so we will be releasing an updated draft version of SPD 41 to include some of these changes. And as mentioned, we'll be giving an opportunity for public comment on those before adopting them. But some divisions may enact these policies earlier, and that these new policies will only be enacted once adopted. But as mentioned, these policies also represent a kind of minimum expectation, and some of the divisions are, and for example, the results do take things a step further. And if you go to the next slide, I think we have some of these proposed highlights. For example, that we should be actually making sure that our data is fair, findable, accessible, interoperable, and reusable. We should be making use of persistent identifiers both for our funding mechanisms and our missions. Our data collection should also have digital object identifiers and metadata available to make it easier to find the data. Our researchers should be using ORCIDs to help actually provide or should have a persistent identifier such as ORCIDs. And as Kai mentioned, mission software shall be developed openly, allowing for community contributions to actually make it as accessible as possible. Next slide. And that scientifically useful data should be made publicly available at the end of the award. SMD funded software shall be released as open source software. Peer-reviewed data and software shall be recognized as having commensurate value as peer-reviewed manuscripts, and that there'll be further guidelines on compliance with the policy as well. And so if you go to the next slide, this kind of shows kind of our current schedule for the policy and development of it. And so we'll have basically SBD 41 was released in September. We're hoping to release the RFI shortly and to allow public comment period between November and January on the implementation of the policy. And then we'll be actually having a period of review and revision and then adoption is applicable in our other programs and aspects. And so if you go to the next slide. And so some of the next steps in our information policy, we do want to really focus on automation. How do we make this as easy for both our community, both internally, our groups working within NASA, and our community of scientific researchers? We want to provide further guidance from each of the different divisions to actually give guidance and what compliance with the policy means for your community. There are different aspects which are going to be specific to each of our different communities, but we're also going to provide training. As mentioned, TOPS is a very transformed to open science, is going to be one of our big activities especially over the next 2 years, but also going forward to actually get people to adopt these open science frameworks to help them move forward. We'll provide support for open that are needed to support this, and that's something I'm certainly hoping to hear from this community about what are the next steps here to make this easier for both our missions and our researchers in our community, and identifying metrics and assessing compliance. How can we make sure that we are actually meeting our goals that we're setting? Next slide. And so an example of a division providing more guidance is, Kevin has already shown this, along with the information about, that of openly developing the software and publishing as open access and having open meetings, that these are all great examples of kind of that further guidance and leadership on openness that, we're hoping to see from all of our divisions. Next slide. And so one of the things we'd also like to make sure that we're actually supporting it and making it easier for everyone. And so one of the things that we're actually doing is supporting open source software. We've had the E7 call on open source tools, frameworks, and libraries. We're also have supplemental calls to help groups transition from having closed software to open software. And one of the and probably very important for this group, and I'll post my email also in the chat. We're also working to improve the software release process for NASA civil servants and missions. There currently is conflicting guidance between the software release process and current NASA policies, and we're currently engaging across different groups to help improve that process. I think everyone does want to see that process improved, but while still maintaining the security and review process that is necessary to ensure the quality of the software that we're releasing. If you do have questions about this, if you have engagements or thoughts about the software release process, please reach out and talk to me. I'd be very happy to hear about them, and I'll post my email in the chat for everyone to get in contact about it. So if you go to the next slide. All right. If you go to this seems like an older draft of some of my slides. And so if you go to the next slide, And so as mentioned, we want to increase access to SMD publications. One of the things that we're doing is supporting ADS, which is the Astrophysics Data Systems, which provides access to basically searching. It's been in place for about 30 years for searching the astrophysics libraries and journal publications. And it has provided linking between publications and software and data, and providing kind of an integrated way for scientists to actually search and interconnect this information. One of the things that we're doing is expanding ADS to heliophysics and planetary science. ADS already includes all of the AGU publications. I'll also post a link to them to and include it in what will be actually going further to actually look at how to actually further include other aspects. And if you go to the next slide, and one of the big questions that we do have is making NASA's data accessible. NASA has a fantastic legacy of making our scientific data freely accessible and widely available. We've been a world leader, and I think, especially in earth science, have definitely demonstrated the amazing impacts that can have on discovery and accessibility. And but what are the next steps, and how can we innovate? And I think these are actually very important questions for this group. We do have a number of current OSSI activities which are either going on or going to be kicking off, looking at S&D data catalog search, which is being led by Kaylin Bugbee. There's also work looking at standards for NASA data, which hoping to provide more and further guidance, which is being worked on by Kaylin and Mark Parsons. Learn about all these different tools and how to actually make more advantage of things like cloud computing. But we do have a lot of open questions about, how do we really make our research data, not just our mission data, accessible? How do we ensure our data is accessible by all? How do we further empower citizen science? How do we make our data fair? How do we efficiently handle the large volumes of data and enable interoperability? And how group here. And so very much looking forward to hearing your thoughts about these.
Remaining, Steve.
Perfect. And I think if you go to the next slide, I think that will be my last one, which is also just to highlight the next steps on the policy. The RFI will be released hopefully by the end of the month, asking really how will the proposed changes to the existing information impact the research activities of your communities, and what services, training, funding, or further guidance is needed to support the successful implementation of the policy. In the meantime, and even outside of the RFI, questions can be sent to hq-smd-sbd41@mail.nasa.gov. And I'll post both that and my email address in the chat. And looking forward to hearing what you're talking about for the rest of the meeting, as well as engaging with you on the policy. So thank you very much.
I don't. Hi, I'm Katie Baines. I am Kevin's deputy of the Earth Science Data Systems, and he has just asked me to mention that there's a community town hall for all of Earth Science Division on Thursday. So do be, bring your questions to that meeting as well. All right, so let's move on to my next slide, and I'm going to bring it sort of more into the context of, after we've talked about policy, and Kevin has really done a great job of setting the stage. Let's bring it back into, the the topic of this meeting is the Earth System Observatory, which really involves all of the scientific questions that we're trying to answer coming out of the decadal survey. You've all seen this graphic. I think it is a lovely representation of all of the components coming together for this system. So what does all of this mean in context of the data systems in particular? So let's move on to the next slide here. As Kevin and Steve have both sort of talked about being an open source science initiative that we're working with now, it really involves beginning this open science activity further to the left than we have in the past. Part of the way we've engaged in missions in the past is really in the phase C and D, where we're developing the scientific data products. We're finalizing all of the data volumes and the project agreements between a DAC or an archive and the mission. And we want to start those conversations earlier in the process, because we're going to be part of open science is providing insight into the entire scientific process. So as the ESO missions, at least the three resulting from the decadal that are in pre-phase A right now get underway, we want to make sure that you are aware of everything that we'd like to have happen during those things. And so let's move on to the next slide. So I'm sure you're tired of seeing this slide, but I do want to just hammer home that this is really what we're trying to accommodate within the data systems program, making sure that all software is developed openly. And I saw the question in the chat about things that have been done already and how we are going to accommodate those. And I'm looking forward to having those discussions as the time progresses. But all the software that should be developed openly using permissive software licenses. And if this means that these licenses should be in the Apache style, which means that you can bring in code from elsewhere, you can contribute freely, and allow for community use and contributions and mashups as well. Manuscripts shall be published with open access licenses. I think Kevin spoke to that as well. And we've been doing something within our science data systems to enable that at the algorithm theoretical basis document level. As has always been the case, data, calibration, information, simulated products, and supporting development validation will be made available without any conditions to use. We're also talking about any data that would be used exclusively for testing. Obviously, the metadata, software, publications, and documentation shall be archived at the DACs as early as possible, and should be properly marked, cited, and attributed. I don't want to reiterate too much, but there will be an open source science plan that we're working on a template for that'll be carried forward for that. So let's move on to the next slide. So this, if you're on this call, you're probably aware of our Distributed Active Archive Center, which is really the discipline-focused archives that manage data that is produced by our scientific missions and campaigns. And historically, they have all been working, to serve their independent communities. They all have their own set of system administrators and disks and ingest and archive systems. And as we move into the future, we envision that these DACs are moving away from a lot of these generalized activities, managing tape silos and things like that, and moving much more into focusing specifically on the scientific endeavor and the scientific process. So they already are, real examples of excellence in data and metadata stewardship, ensuring that the data that is archived and distributed is of the highest quality and as documented as possible. So that'll be continuing to be an expectation going forward. But we're also looking at increasing our linkages between data resources and publications that result from those data archived data. So we're looking at involving, semantic searching, graph technologies, NLP, and machine learning techniques to sort of improve our information level management And this is of a piece of what we've been doing within the program for many years now. And I'm sure some of the people on the call have been participants in that. We are going to be expecting as we go forward that the DACs become better enabled to manage open source software and support open source software. Documenting that software, making sure it is cited, its metadata is cited, its usage is explained and documented, and really becoming the long-term archive and sustainers of these and supporting users. This is a change from what has been historically the case. We're also looking to engage the DACs more in cross-mission science, and I think we've seen this, this cross-archive collaboration, in fits and starts in the past. I think we're going to dig deeper into that sort of cross-use and cross-discipline and science reuse as we move towards an Earth Science Observatory, which is really bringing a lot of these data to bear in a single place and a single sort of unified data archive. And in addition, we have the Earth Data Forum, which is currently serving, I think many of our DACs are utilizing it to have conversations with their end users out in the public, really part of engaging other folks who can come in and see what other problems have been experienced by other end users, give advice amongst each other, really support each other. And this spirit of collaboration and community within the DACs, we're hoping to carry forth and expand and broaden our engagement with those communities as we go forward. So, next slide. A lot of the things that we've talked about with respect to open science have already, from a technical perspective, have already sort of become underway, and hopefully you can tell the colors here. If it's green, it's really already in operations or has already been established and is working. Our common metadata repository, which is where we keep all of the metadata for, I think, over 10,000 Earth Science, NASA Earth Science data products as of, I think, the last update I saw, and over, 500 million data files or granules that are indexed in that common metadata repository. That project is open sourced. It's native to the cloud right now, super fast, and actually getting traction outside of the NASA community for reuse. We're adding open formats to that, the Spatial Temporal Asset Catalog, or STAC. We're really looking at how the community is evolving as we move to the cloud with our data products, how we can enable search that's more interoperable and broadly used across not just NASA, but internationally. In addition to that metadata repository, we have a cloud-native ingest and archive and distribution system called Cumulus, which is also an open source project that has been picked up and adopted by other groups that really are focusing on focusing on reusable workflows that can be applied. And now out of our 12 DACs, 8 of them are either operationally using the Cumulus system to ingest their data actively into the cloud or are prototyping to adopt it in the future. Steve just went in depth on the new policies that are in place, and we are starting to modernize our advanced metrics collection, now realizing more than ever before that the amount of data downloaded or the amount of files that are distributed is not necessarily representative of success. And we really want to look into how we can delve into the usage of those archives and how the data is cited in scientific literature, and how clusters of folks use different types of data, and really just looking at it with advanced techniques as we move into the cloud. Now there are other, I've sort of covered the green elements of this chart. There are lots of things that are currently continued to be in development. The Earth Data publication and the algorithm publication tools are both tools that are focusing on streamlining the process that a DAC might use to get, and a science team might use to document the work that they're doing and get their data into a DAC archive. So those are definitely being worked right now, and both, I believe, are open sourced as well. In addition to that, we've been looking at algorithm and analysis platforms. This is really looking at how we can move scientific collaboration forward through the use of Jupyter notebooks and collaboration. And that is a joint project that we're undergoing with the European Space Agency. And in addition, when we look at increasing transparency and inclusivity into this, we have a tool like the COVID dashboard, which is really kickstarted by the COVID-19 or the EO dashboard, actually is what it's called now. And I'll drop a link in the chat for this meeting. Really looking at interactive exploration and on-the-fly graphing of data values to really open up these things for exploration to the public at large. And the things in formulation now, you're actually sitting in one of the meetings that are part of that. So we are looking at streamlining algorithm development and data production, how we can improve our model, our usage of modeling and observational data together. So those are the things that we're really actively investing in now and looking to formulate plans for the future. And of course, this is the first step. Next slide. Oh, backup slides for right now, I guess. Again, I think we had a little bit of a CM issue here. So I really did want to encourage you as we go forward to engage with this meeting, and don't forget to go to the town hall. Thank you, Sarah, for dropping that link in the chat, and I will pass it over to Andy Bingham, who is another host of this meeting. So thank you.
Okay, good morning. Hope you can all hear me. Thank you, Kevin, Steve, and Katie for the excellent introductions there of what's going on at NASA in terms of Earth science data systems and data and so forth. That was provides great context for what we're doing here. So I want to start now, sort of moving us forward now into the. Sorry, could we just stay back on the first slide? I just want to. Move us forward into this, what we're doing with the processing study. So this is all focused on the ESO missions. So that is, of course, it's SBG, AOS, mass change, and NISAR as a precursor for SDC. So with the dawn of the ESO missions coming together, there's a strong interest in NASA to study Earth as a system. And of course, as you've been hearing, to do this in a very open way. So with that, Kevin's asked us to put together. There's an opportunity here to look at how we do mission data processing. So a few months ago, he asked myself and Andy Mitchell and other folks here, Shell gentleman from the Farallon Institute, and also Luke Dow from JPL, to put together this study to study this problem. So next slide, please. So Kevin, the goal that Kevin basically gave to us was to really to identify and assess potential architectures that could meet the ESO mission science data processing objectives. And with that, he wanted us to promote the open science principles that we've been hearing about. He wants us to look at data system efficiencies, so rather than having all missions doing their own data processing alone, do we have opportunities for reducing costs, reducing the way we do business across the whole system. It's also asked us to look at if there are opportunities to support Earth system science, and also to expand participation to mission science beyond the current funding approaches science teams and the way we do business today. So that was the study goal that he laid out to us, and with that he also gave us some guiding principles. Next slide, please. Next slide, please. Thank you. So with this study, Kevin asked us to put together a system architecture working group that would be looking at all these potential architectures. He wanted the team to be made up of experts in science data systems that represent the full diversity of the community that we represent, and also we're looking for folks to be part of this group that have strong connections to the end science communities. Additionally, the team needed to be made up of members from the ESO missions, so we're maintaining that connection back to those projects and having the ability to reach back to understand what they're trying to do, what they would like from the mission needs as well for this study. So opening up that communication to the missions was critical to the success of this study. We heard, following the ideas of open science principles, all our meetings will be held open in the open. This workshop is being recorded. All the artifacts that are being generated from this workshop and future workshops will all be citable, have DOIs and accessible through our study website, and also we'll be moving towards using GitHub as well. We do anticipate there'll be one-on-one meetings that are happening between the study team and other entities throughout this study period, and with that, we're asking that the notes are collected for those meetings and that they too are made accessible. And the other guiding principle here is to ensure community participation. So this is why all of you are here today, and hopefully we've been able to provide you with mechanisms to provide your feedback during this workshop and as we move forward throughout the study period. And we're also being asked to actively seek out feedback from communities that have been historically excluded from the science processing system. So we are looking to try and reach out more actively than we've done in the past. So those are the guiding principles that Kevin has laid out for us. Next slide, please. So I think it's important to first to stop a little bit and just identify the scope of what we are asking the study to look at. So this is our definition of what mission science data processing system is. We include the set of algorithms, the software, the compute infrastructure, all the operational procedures, and the documentation that are used to take raw instrument data and process it through to archivable science quality data products. So that, the little box down below, the blue box, is sort of showing that we have the raw instrument data coming in along with any ancillary data going through to the, being processed through to the science products, which could be level 1, level 2, and potentially level 3 products. As part of this system, we're also including the software tools that support the development of those algorithms, as well as the validation and any analysis of those processed data. So that's the scope of the mission science data processing system. Next slide, please. So here's a very high-level architecture of how things would be working today if we didn't do anything, if we just carried on business as usual. On the left-hand side there, we have each of the ESO instruments up there flying around in space, collecting some fantastic data of Earth, downlinking the data through a multi-mission capability, the near-Earth network. Then each instrument going through to their own data processing systems and sending data over to an archive, again, a multi-mission archive approach through the DACs, and then from there out to the end user community. So this is pretty much the architecture that we have, very high level of what we're doing today. Next slide. So the question that really we're trying to address here, it comes down to, is could that central box there with the data processing systems, can that be multi-missionalized? Do we have an opportunity to have a tighter integration across the missions? And if so, what would that look like? And with that, we're opening up that arrow between the end users and the data processing systems to provide greater openness and to support all these open science objectives that we've heard about already, as well as that little red line down the bottom, right? Now that we've got everything with things more integrated, do we have an opportunity to really start thinking about Earth system science data products and getting those out and producing those? So that's next slide. So that really the focus then of this study is to take a look at what those components might be inside of that box, and do we have the opportunity to reimagine how we do the data systems of the future. Okay, next slide. So to address this problem, we've put together the steering team who you've all met now. We've also got support with Karen Yuen and Sarah Lubkin, who are here helping us along today. And we've put together our system architecture working group. The co-chairs there are Elias Safi from JPL and Natasha Stavros from University of Colorado. We have put together, we've collected the names of all the people that are now representing the communities, part of this working group. We have members from the ESO missions. We have members from the community, and also we've brought in other people that have deep experience of building large-scale processing systems. We do have one seat currently open, and we're looking to fill that in the course of the next few weeks. Next slide, please. So obviously the system architecture working group is a very important group here, and this is basically their charter that they're working to. We're asking them to collect and evaluate all the architecture drivers. So that means bringing together, understanding all the goals of the program offices, from the programs from NASA, the goals that they want to achieve here, understand their constraints, and also any opportunities they see. We're obviously need to align with what the mission objectives are from the ESO. So we're trying to understand their objectives and their requirements. We'll be evaluating and pulling in the understanding the state of the practice in open science and data processing, big data processing that's going on around the entire country, right? Not just earth science, but beyond, as well as also looking for what's happening on the international scales as well. And also they're bringing in together recommendations from the community. So with all those inputs, the working group will be charged to go off and do a trade study. They're currently working at the moment to figure out what that trade study, how they're going to conduct that trade study. But the goal here is to look at the viable architecture options, and also look at some of the implementation approaches to that. And with that, evaluate that full trade space and come back and make a recommendation to Kevin on what the technical solution might be for the future. And we have to be quite clear, right? Even if for now, they may come back and say the current way of doing business is the right way of doing it. And that's a perfectly okay response. And another on the far extreme, it could be that they come back, we have a fully integrated solution. But there's obviously going to be a whole spectrum of approaches in between those two extremes that they'll be looking at. So yeah, again, the end of all this is to document their entire approaches, document everything that they've collected along the way, and provide that final recommendation. So next slide, please. In terms of the schedule then, or the approach to doing this study, we're here at workshop number 1, where our focus here is to learn from the NASA program managers of what their constraints and opportunities they see, and also hear from the ESO mission. So this will be the remainder of this work today, and all of tomorrow will be focused on receiving that input. There will be a second workshop in the February time frame. We are hoping to do that in person, although COVID issues are starting to raise some problems there. We may end up having to do it virtually, but at the moment we're still trying to do it virtually in person. That will probably be a 3 or even 4-day meeting where we will be looking at the state of the art in mission data processing systems broadly, as well as open science. And with that, we're going to be trying to get some input from industry, have them come out and talk to us about what they're doing. We're probably going to be do this through an invitation only. But if you're interested in presenting or at that meeting, please reach out to the study leads, and we can include that as we put the agenda together. Following that meeting, in the April to July timeframe is when the study, the System Architecture Working Group really get together and start doing their work. We anticipate during that period that they'll be reaching back through to the ESO missions, reaching back to anybody actually from all the information they've heard up to that point to clarify and to get more input. And then we will be having a workshop number 3 in the August timeframe that will be done virtually. At that point, that's where we'll hear the recommendation from the working group. Okay, next slide, please. Okay, so just to set the goals for this workshop, then as I already said, what we're really interested in hearing is the requirements, the objectives, the constraints that are driving the mission data processing systems. We're also seeking to hear opportunities that the speakers see for advancing data systems into the future. We have a lot of people here that are not speaking, but if you do have some ideas on how we can meet some of these 4 guiding areas identified here, or any feedback, right? So please provide that through the course of this meeting and beyond. We do want to hear your ideas on what we could be doing for the future. And really the main goal, well, another goal for this meeting is to really sort of make those connections between our working group and the programmatic and mission points of contacts. Our goal here is to really want to emphasize our goal here is to co-develop our ideas and concepts into the future. So this is just a starting place to really bring everybody together to have that first conversation. But I anticipate there will be a lot more conversations that will happen following on from this. So the result of this particular workshop will be a report summarizing everything we found, and that will be made available through our website. Is there another slide? I can't remember. Next slide. Is there another slide? Hello?
No, that's it.
That's it. Okay. So with that, I want to just thank all the speakers for coming and providing all your input. And again, I want to encourage everybody that's on this telecon to ask questions. We are going to give priority to questions from the System Architecture Working Group, but anybody else that has any other inputs or thoughts or questions, we do encourage you to ask and help us drive the conversations forward. So thank you very much, and I'll pass it over to Karen.
Thanks, Andy. Elias and the other working group members.
Yeah, hey, Karen, this is Elias Saifi, co-chair for the SAWG. We do have some questions that we're sort of collaborating on in our Google Doc. So I can start with asking some of those if you're ready for it.
Please go ahead.
So here's a question sort of, I guess, more for the folks that are sponsoring the study. Given that the SDS doesn't contain all the mission data, and we're seeing that very much with the newer Earth missions like SWOT and NISAR and so forth, the majority of the data winds up at the DAC. The SDS is sort of has a rolling storage of this stuff. What is sort of the boundary of this study in terms of the data processing systems versus the DACs? I know we're sort of clear on, you know, the data system is from level 0 to level 4 and, you know, that kind of stuff. But given that the data is really winds up at the DACs, how much leeway should we should we have in terms of thinking and including that sort of softer boundary?
So I'll take that one. I think that, I think in Katie's slide, she had a great, slide related to science enabling centers. And we're not only interested in like the production of software, the production of products, right? And kind of offloading those to DACs eventually. I think we're also really discussing, where do we put the manuscripts and where do we put the software and who does the support for those activities, which was kind of the idea of science enabling centers, or maybe DACs reimagined. So I think how we have those, like, I think that line is a bit fuzzy. I think that this study is meant to help kind of clarify where those responsibilities begin and end, and also what the mission's requirements would be on a system that as dismanages, right? So if it turns out that we need one or two solutions or something like that related to like hosting open software and maintaining open software, that could be one answer. If there are performance requirements related to processing or reprocessing data that's kind of like the stewardship performed by a DAC, that has to be considered, I think, within this discussion. Also, like, how do we do collaboration across teams? What tools and techniques are needed for that? So I think there are some fundamental things related to how we develop products on a mission by mission basis, but I don't think ESO, doing Earth system science with the whole host of measurements we take, including, ones that have already been, acquired through our program of record, are outside of the scope here. Because ultimately, we want to be able to create products that are fusions among multiple missions, for, either consistency or longevity or just completeness.
Okay. Yeah, that's exactly the kind of answer I wanted to hear. Thank you for that. Andrew Michaelis, you had the next question.
Yeah. Hi, I had a quick question. There's a lot of talk about releasing software outward, and I was just wondering what some of your thoughts are on, how we might incorporate software from external groups, companies. What are some of the hurdles, in terms of legal, IP, incompatible open source licenses and things like that from legacy software that you may want to bring in or maybe want to buy? What is the thinking? Like, is we can only use open source software of a certain license type, or I don't know, just curious on your thoughts.
Yeah, so I think we have some work to do, and I think Steve Crawford mentioned this in his presentation related to software release at NASA. So that's the first thing, right? And the second thing is that we have to be careful in the types of licenses that we choose. We've typically been using Apache 2 licenses for a variety of reasons, but there could be potentially better licenses out there. But I don't think that we all want to go select our own licenses for our own reasons. So we'll have to provide you some guidance on that. The next thing is I think, this is a lot of question. You had a whole bunch. This is a really compounded question, but the next thing is like, how do we deal with, okay, we've got open software that we're developing. How do we determine if we, accept community contributions, and what is the process to do that? I think that's something that we got to work on and we've got to work out. Certainly, groups like Apache have done this, and there are other models out there for taking community contributions, or actually just enabling, groups to be responsible for modules and having and delegating those responsibilities to them. And that process question is a big question about how you do open science, right? how you do open source science is a question of how do you bring in community contributions. And we need to work that out too. But there are models that exist. We don't have to reinvent it from nothing. So you know, these are kind of a whole bunch of non-answers, but we are going into you know, a kind of a new era of transparency and support. I don't know, Steve, if you have anything you want to answer or add, or Katie.
Yeah, I just wanted to add one. I fully agree with everything that Kevin said there, and I think we'll be providing more guidance. One aspect of guidance that I can provide now is to start early, especially if you're working with a specific NASA center. Engage with your software release authority early in the process, and also feel free to reach out to me, that we can actually help try and answer some of these questions, and then also be able to provide that further guidance for everyone.
Can I do a quick follow-up on that? So you mentioned, work with your center on some of these issues. Is that how are you communicating these new policies and potentially new processes for incorporating software and things like that with the center legal and software release people? Are you going to have like a workshop or something? This is kind of an aside, but I was interested in how that, because there seems to be kind of some disconnect between.
Well, let me do two things here. And then, Steve, I'll let you answer in just a second. The first thing that we're going to do is we're putting this as a requirement in any of our contracts or our, other solicitations, right? So we're going to make it a required deliverable in these activities. We've talked to the flight program about this. We've talked to the earth science leads at all the centers during our tag up about this. More formal guidance is going to be necessary, but just assume that you'll see it in contracts, in task orders, in those types of activities. So that's one formal way that we can do it. Steve, maybe back to you now on how we'll work across on the policy sides.
And I won't disagree that there is a disconnect, and that's something that I'm trying to engage with the different groups to help address. I don't have a specific answer about how that will get, or about the resolution of that, but that is something that we're actively engaging with different groups to help address, and that there is consistent support for open source software across NASA for our scientific projects.
Very happy to hear that. Yeah, thanks.
Any other questions from the working group?
Yeah, we did have another question. In terms of the study and looking at the overall constraints of the study, how much of this do we assume that the currently funded ESO missions, that they have to cover within their own existing costs, or can we sort of assume that whatever this architecture that we come up with will have some aspect to those added requirements or added costs, and those will somehow be addressed later, both in terms of maybe more liens or money for those missions to do those things? Or should we feel constrained that we need to stay within their existing funding profiles?
So I think that we stay within the mission funding profiles for the work that they are supposed to be performing, right? And I think too that as we look across the various kind of ground system and data production architectures, there could be things that we can do together, or that the first mission out of the gate could do for the benefit of other missions, and we should really look to identify what those are. However, historically, funding for the data segment or the data system segment, like the DACs, has been borne outside of the missions, and that will continue to be the case. We will have a little bit of additional funds to support the development of common services that span multiple missions. And exactly where we draw the line in kind of the architecture is something that we'll have to discuss with the advisory group and through these meetings. So, I don't think, if I just took a broad brush approach at this point and just said, hey, missions are probably going to be responsible for the things that typically have been responsible for, which are, the production of the level 1, level 2, level 3, or whatever products that exist, then or that exists in the PLRA, then that's pretty safe. Exactly where they do it and how they do it, I think is something that we're gonna figure out over time. NISAR is a pretty good example of this, right? We started working with NISAR pretty early, and got that relationship between NISAR and the ASF DAC and Earth Data Cloud. Really kind of did a whole pathfinding and trailblazing activity with that, so that we could minimize some of the costs for storage of data, for instance, like that previous question asked, right? So where we can blur the lines to have more money to invest in science because we do it more efficiently, I think that would be definitely interesting to us. And maybe like in the NISAR case where the full mission archive didn't need to be saved more than 1 time or 2 times or however many times we do it for redundancy, which is a substantial amount of data, that allows us to do more things, right? So that's what we're kind of looking for here, as well as how we work across the missions. So that's also kind of a waffly answer, but just assume that you're going to be doing what you did before, and if there are things that you can make a bit more robust so other people can use them, that would be really appreciated.
Okay. In terms of at least the focus so far, there's been a lot of focus on sort of open science, but the study has multiple goals, right? It's supporting not just open science, but also enabling sort of an earth science system and identifying these efficiencies and things. When you're sort of looking at this as a whole, do all of these things have similar weight, and should the team even take that into consideration, or should we just say, here are the goals we're trying to achieve, here's the architecture that may best meet each of these, but there's going to be some that meet one of these goals a little bit more than the other? Should we put weights to those and think in that way, or should we allow that study and present the information, and the decision as to which one makes more sense can be made by either the larger community?
So open source science is kind of it's at the principle level, right? We're doing this to be open. We make our information available to people so that we can advance science, so that they can make decisions based on the information that we provide. So I think at the basic level, that openness principle has to be a core activity. I think in terms of priority, however, certainly we need to have missions do what missions have traditionally done and always will do, which is produce high quality products, because that's why they were initialized. But I think we increasingly have to look at how those products will integrate with other measurements and be complementary going down the road. So I'd say that you got to do the work that you've got to do to make your mission a success, closely followed by looking how it works within the ecosystem of the other products, including modeling activities, honestly, all while being open.
Hi, everyone. Let's see. We are going to get ready for our next speaker, who will be Katie Boggs. Katie, I know you are in. Can you hear us? Katie?
Thank you. I could hear you, but it said I couldn't unmute myself, so.
Oh, I apologize. We just unmuted you. Thank you. Go ahead.
Okay, you ready for me? I guess. Okay. So hello. I guess for many of you guys, you don't know who I am because I'm fairly new. I've joined Earth Science Division as the Deputy Associate Director for Flight Programs. So I am Charles Webb's deputy. I just joined in May, so all this open source science stuff is really new to me. So if I say something a little funky, just bear with me because I'm still learning, and excited to be here talking with you guys about all of this. If you can go to the next slide. So really, I'm not going to take anywhere near the 15 minutes allocated, and because I know actually, since our role is overseeing the development of all the ESO missions, I think the more important contributions here are coming directly from the projects, and I'm not going to duplicate what they have to say there. But from the flight perspective, at that management level, we just have a couple things that are concerns and reminders to everyone as we work through how to do this. First of all the ESO missions are in formulation, and really trying to work through, or I guess they're in pre-formulation, but we really need to early on understand concrete requirements for open source science, and they have to be provided timely enough to support those formulation activities so we can build it into the baseline. And for those of you guys who don't live in 7120.5 world, it can be quite challenging to get a project baseline put together. And so we want to make sure that we have this in there, it's accounted for, and that we're going forward with a whole up mission plan that includes this important work that we're going to do for open source science. So in order to get things approved, we really need this to be done in a timely way, so we can make sure it's in the baseline and accounted for. But we also need to be realistic about what we can implement. So everyone who's formulating a mission here is balancing all kinds of different requirements between the data systems, our engineering program management requirements as outlined in 7120.5 and 7123. We have emerging cybersecurity stuff, and today we're talking about challenges around these mega constellations, and actually Spectrum is part of that. So there's all kinds of different things, and as you guys know, we're always trying to optimize and work through it. But so I really just want to encourage realism, because there's going to be some things that are going to seem like fantastic ideas and we want to do it. And there's going to be some policy or something else in the way. So, I want to look for creative solutions. But at the same point, we do have to balance all these competing needs. And then, finally, I think one of the things that, concerns me, and my brain does tend to go to policy a lot. I think we need to be deliberate and consistent in our external messaging regarding open source science implementation on our flight missions. So, I think Kevin and the team have done a really fantastic job of, getting out and talking about open source science and what is it and why are we doing it and why is this important, for NASA and for the nation. But, when it comes to how are we actually implementing it, when we start talking about this and what we're doing on specific missions, I would like to see some consistency about how we talk about it across missions. I think that helps us as an agency, and as we're trying to, encourage the public to engage on these activities. And one mention recently in one of our staff meetings was that OLIA had, or that's Legislative and Intergovernmental Affairs, mentioned that some in Congress hear the words open source science and they immediately think that NASA is giving away state secrets. you know, I say that kind of flippantly, but there's some real concern there, and we have had people, you know, stealing technology that was developed at NASA for not good uses. So one of the things to think about that is, you know, what are the set of messaging around this whole thing that shows that this is, you know, it is, and what it is versus what it's not, which is not, you know, a security concern. And so, I mean, like I said, it's short and sweet. You know, why am I here and listening and you know, why do we care about this? Of course, everyone's all covered it. I think it's the right thing to go do. And, you know, Flight, of course, supports all this and the hard work you guys are doing for it. So I don't really have anything else to say here. I guess, I mean, I'm happy to answer questions if there's something burning.
Katie, I think we'll take questions in the chat because we're monitoring that, and we'll leave that after the other speakers for the working group to address. If you don't mind, we could jump ahead and have the other speakers go ahead.
Yep, that would be great. Thank you.
Thank you. Could we please bring up the charts thank you. So Ben and Jacqueline, are you on? Can you unmute?
Yes, I am unmuted.
Thank you.
This is Ben. I'm here too.
Yep. Okay, so we will give the presentation collaboratively with Ben Smith. We are both from the Advanced Information Systems Technology program, which is part of the Earth Science Technology Office. So if we can go to the next slide. So the Earth Science Technology Office as a whole is a technology component of the Earth Science Division. And as part of ESTO, the Advanced Information Systems Technology Program looks at information systems and novel computer science technologies that are expected to be needed for Earth science in the next 5 to 10 years or 10 to 15 years. So as part of AIST, we currently have 3 main thrusts. The first thrust, the New Observing Strategies, NOS, and the Analytic Collaborative Frameworks, SCF, have been defined and ongoing since already probably 4 or 5 years. And the newest thrust is the Earth System Digital Twins, or ESDT. So NOS looks at coordinating and collaborating observations across multiple platforms to be able to acquire better observations of Earth science phenomena. And this can be done as before the mission as a mission design with a mission design objective, or it can be done within a mission with targeted observations. So it really looks at the beginning of the data life cycle. If we look at the little diagram on the left, at the bottom, the NOS looks at the first part of the data life cycle, while SCF, Analytic Collaborative Frameworks, takes all the data and the observations that have been acquired by NOS-like system and harmonize all of this data across various geographic scales, latencies, and frequency, and facilitate the access and the integration and the understanding of all of these different data and observation. And this really corresponds to the second part of the data life cycle. And if we look at these 2 main thrusts and build on top of them, these really represent the stepping stones, the 2 stepping stones towards a better understanding and simulation and investigative analysis of this different Earth system, and this is what is covered in the Earth System Digital Twins thrust, which is a very new thrust that is just starting. So STF really is a thrust that responds to the challenges and the issues and the questions that we are discussing in this workshop about open science. And if we go to the next slide, we have a certain number of in the AIST portfolio. There are a certain number of projects that respond to this SEF thrust, and that Ben is going to present today. So all of these projects represent, and all of the AIST projects usually start at the TRL level between 2 and 4, and at the TRL 4 to 6. Some of them go a little bit further in the TRL maturity, but they usually represent some technology innovation that then it can be used by other program and operating systems to either as a knowledge transfer for ideas of technologies and where to go, but so in some cases these projects are mature enough for a transition or infusion. So as you can see on that slide, many of these projects respond to the challenges of some of the ESO missions, and without taking any more time, I am going to let Ben go into a little bit more detail about the SEF thrust and these projects in particular.
Great, thank you, Jacqueline. If you go on to the next slide. All right, so I'm Ben Smith. I'm one of the associates for AIST. So I'll be talking a little more about analytic collaborative frameworks and some of the technology highlights there that relate to this ESO workshop. So analytic collaborative frameworks are basically a capability that allows to bring together science data tools and analytics from a number of different sources into a single platform, and then this allows then the science community to do analyses within that environment. So it brings together the rather than having to go out and get individual data that you need and assemble it on your laptop, you can bring this together into a single portal along with your tools, your analytics, visualization, search, all of these different kinds of capabilities, and then it also provides capabilities for collaboration as well, which I think is another piece that feeds into open science. And then also, in addition to building analytic collaborative frameworks for individual science disciplines, and another important capability here is federation, which is allowing these frameworks to talk with each other in order to share data, which expands that open science even further. All right, and I think we've touched on that some in terms of like cross-mission science and things like that. So very much in line with that. If you go on to the next slide. All right, so here's where I think the analytic collaborative frameworks tie into this workshop, the mission data processing and open source science. So one is it provides this collaborative analysis environment. So that allows collaboration both within science discipline and then also across them to lead into things like open, cross-mission science and analysis. Also, because you've got all your data tools and visualization there within one portal and a cloud framework, that lends itself very well to the sharing and that's important to open source science. So by nature, it is essentially open source. The data is there, the tools are there. You can point to, you have the ability then to point to the provenance and share your work. So at least all of those kinds of principles. And the middle column there is the low latency data processing. So in addition to the sharing, then as we start getting into larger data sets and more compute intensive workflows, being able to process those is important. So some of the AIST projects are looking at various aspects of that. So high performance workflows, scalable workflows, hybrid cloud architectures, and also bringing models into this, as well as analytic tools is also a key aspect. And so there's some work there I'll touch on accelerating models and bringing those into the cloud as well, so that those can be included in workflows. And then finally is a capability to analyze multiple data sources, so both within a discipline or a mission, but also across them. A number of the ESO missions are either looking at constellations or multiple instruments. If you also want to bring in things like in situ data, airborne data, or look across different missions, then some of the analytic center or analytic collaborative framework capabilities are important to those. Both in terms of being able to bring them together and to do analyses across them. So if you go on to the next slide. Here's one example. This is from AIST 6. It's from a few years ago. So this is in the previous solicitation, but we had something called OceanWorks. So this brings together a lot of different data sets and analytics for ocean science. And just to give you an example of what an ACF might look like, so this brings together all of these sources. You've got ocean data sets from a lot of different sources, cloud-based analytics. Users could bring their own custom analytics and run them in the cloud environment. It takes care of integrating the data in terms of doing matchups and search over that, and providing some common APIs for that. And then search and visualization. So you can see here in the bottom a couple of examples where the user has, say, selected an area on the screen, says, give me data from these 3 or 4 different data sets, plot them for me, and that just goes out and happens on the cloud, and you get your plots and results. And then if you need to save that workflow, you can, and other people can look at that same data and results, and you can share them in Jupyter Notebook. So again, these are things that feed into that open source science. Okay, next. Key part of this is open source. So AIST requires that its developments through its solicitations are released open source. This particular platform was released as through the Apache Software Foundation. Not only does that facilitate open science, but it also facilitates infusion and adoption. So I just wanted to underline that, I think, for this workshop. Because of that, it's much easier for it to move into other programs and both the research programs and missions. And then those capabilities, as they're expanded upon in other programs, also feed back into that open source capability. And if you go on to the next one. And that open source also leads towards federating the ability to federate analytic frameworks. So in this cartoon on the right there, you could see analytic frameworks for different capabilities, in this case, wildfires, precipitation, and air quality. So you can imagine a lot of applications where you would want to look at analyses across all of those. And to the extent that they all have are using common frameworks, common data representations, common interfaces, that is going to be much easier, and you can now talk between those and do some very interesting kinds of science with relatively low friction that might have been difficult to do otherwise. So I think that's federation is something to bear in mind as we move forward on the ESO frameworks. All right, next. All right, so and then I'm going to quickly touch on a few of these, and I think I've got maybe about 3 minutes left, so apologies if I whip through these. This is one project called Image Spec. So this is looking at hyperspectral data, and with a particular focus on, as you know, it's going to be something that's coming up in the SPG mission. This is looking at terrestrial biology as a particular focus area, but the point here is that a lot of the hyperspectral data requires, it's more computationally intensive, so we need workflows, cloud-based workflows that will be able to handle that. And so this project is looking at workflows and architectures that will support those kinds of high volume and computationally intensive analyses. There's been some infusion there that's already going on, so some collaborations with Sister, which is one of the SPG related projects, doing some prototypes there. All right, next. Here's another one, which is multi-cloud processing of SAR, ARDs, analysis ready data. We've heard a lot about various kinds of cloud processing. So one of the newer capabilities is multi-cloud. So rather than just running, say, just on Amazon or Azure or Google, what if you could have your workflows be able to work on any of these? And then move jobs back and forth between these in order to figure out what is the most cost-effective way to run those jobs. Also being able to access things like high-performance computing, and how do you include those in your workflow. So that this project is looking on cloud architectures that support that kind of multi-cloud, with a focus on SAR processing in particular, which is also relevant to the some of the ESO missions. All right, moving on to the next. And then I wanted to touch on model-based, including models into this framework. So there's kind of two thrust areas here. One is, can you take models and move them from high-performance computing environments up onto the cloud? If you can run those on places like AWS or other cloud environments, it's much easier to include them in workflows. Also being able to accelerate them. So there's also some work going on in machine learning acceleration. So if you can learn essentially surrogates for the models, those can then, once they're trained, can run much, much faster. So that also allows you to speed things up. So there's some work going on there with geoschem, and there might be further applications. Next. All right, and then finally, I wanted to touch on QuakesA, which is a framework for quakes and crustal deformation data. And the idea here is to bring together a crustal deformation model that fuses a lot of different kinds of data, from SAR imagery to satellite to in situ data. So this just touches on that capability to bring data together from lots of different data sources, and when you do, you can then build products that are more powerful than anyone alone. All right, and next, I think we're on to the conclusion slide. So Jacqueline, I'll turn it back over to you, and
yes.
Thank you.
So just yes, thank you. So just to summarize, we try to give examples of a few of our AIST projects that either offer a potential for transition or infusion, or could be used as a stepping stone for other larger projects. And I am going to start with the very last slide of this, the last line of these slides. The big idea is really to be able to federate these different projects and systems. So not just one is going to be the one solution, but we can federate between these different systems. And we feel that these SCF type frameworks can facilitate open source science. And I think one of the important things to remember is that these frameworks contain some kind of default workflows and tools and data, but the user can bring and share their own workflows and tools and data. And so this can be tailored to the need of the ESO science community. And the second key point to take from this project is that this type of technology can accelerate the generation of information products, and especially when using cloud and HPC processing. And finally, this also allows to bring together some emerging technologies for analyzing various instruments data, which are at various different scales, from space, air, and ground, and with various spatial, spectral, and temporal resolution. So this is a very high and quick summary of what you just heard, but you will have the slides. So I think that's all for us.
Thank you, Jacqueline and Ben. Let's see. Are we ready for Jack K? Jack, I know you were admitted. Can we please have you unmute so we know you can hear us and we can hear you?
Jack?
Yep. Could someone unmute Jack?
Well, to unmute. So,
okay, thank you.
Thanks. Appreciate having the opportunity. See, it's not October 14th. I didn't even get the date right, so sorry about that. So what I was going to do is say some things about what I see as a relationship between what we're doing in research analysis and open source science, including some of the things that we're doing now that perhaps we can look at, learn some lessons, and guide us to the future. So next chart is a reminder of the scope of the RNA program, which for a lot of you know that we advance fundamental knowledge of the Earth system, the different spheres, so to speak, the coupling that connects them, both human and natural induced forcings, and really try to understand variability in space and time, past, present, and future. We also support a lot of the enabling capabilities that help the whole division. We are implemented in a variety of places: NASA centers, academia, laboratories of other government agencies, private sector, nonprofit, mostly through individual investigator-competed awards, but some directed funding, especially at the Centers for Enabling Activities. We interact closely with all the other parts of Earth System Science and Earth Science Division. We're closely connected with the efforts of our interagency and international partners, both bilaterally and through organized multilateral entities. Next. So the template said to say something about the vision for science data processing and open science at NASA. And along with the rest of ESD, really, the RNA program has long had a policy of open data, especially for our networks and field campaigns, and the satellite data products, where really the satellites come out of the flight program, and some of the big modeling results, including the assimilations and reanalyses. There's been increasing publication in open journals. We've heard about that. And there has been some initiation of activities in the past towards open science, or open source science, which I take as not just sharing the products at the end, but the processes and the steps along the way that let us get to where we end up, and giving others the opportunity to participate in that. So to get a sense of some of the kinds of things that we had done, I polled the RNA staff and said, tell me some of the things that you've been doing that would qualify as open source science. And I got a bunch of answers that you can see. And in the interest of time, I'm only going to talk about a few of them, and the rest are in the package, and give you a sense of what people were thinking about when they responded. I didn't filter the responses. So if I asked about open source science, and if they answered something that might be more like the traditional open data products, I didn't filter that. So a few examples before I get to some thoughts for the future. So next, the computational modeling and cyber infrastructure program. This is something that we've done with some solicitations, and we sort of laid out some requirements, took some implementation steps, got some positive results, found some challenges, some lessons learned, and we looked at next steps. And you can see it's a pretty dense chart, and I'm not going to go through all of them. You can see that the NASA Earth Exchange NEX project was an open platform that integrated a number of these things. There's things that we did at Goddard and Ames at JPL. We did some solicitations and got some things that we learned, and then some of the next steps. And I'll come back a little bit at the end. It's a need to change the culture and create incentives to participate in open source science, leveraging the professional societies, and also, in this case, consider inventing an O index similar to an H index. So, and I'll mention something about that at the end. But this is one example of some of the things that we've done. Next is the High Mountain Asia, which is an activity that has been there for a while, and that the most recent solicitation had open source science requirements about the tools, including the glacial melt toolbox, and proposals had to explain how the research would be integrated to and benefit from the tools. We had some open science in the initial HMA activity, because that jump-started the setup of sharing of data and tools, and you got some good results. Found some challenges because it was new for the PIs, and some of the lessons learned that, among other things, that the early career people, including grad students, may be particularly helpful in facilitating the adoption of some of these kinds of things. It's new to them. They're not used to doing things the old way. So if this is the new way, it's the first way for them. Next. And I should say on the HMA, Tom Wagner started that when he was with us, and Jared Enton and Nancy Serby are leading that. Nancy's really been involved from the beginning as well. And then a Cryosphere program, and I sat too. And there's been not just to share your data, but share your knowledge and share your sources, including publishing and referencing codes. You can see some of the implementation steps about getting the community thinking about that. So like I said, to hackathons, incentivizing source sharing by making open science a critical component of the selection process. And the results show that code developed and shared during the ISET2 hackathons are being used and expanded. The PIs are working in community-driven model development, but there are some challenges that getting people to buy in, and some inconsistent guidelines, because if one group implements open source science one way and another a slightly different way, then people may get confused. So getting to consistency will be helpful. And the next steps there include providing partnering opportunities, evolving requirements, developing standardized practices, support open source library development, and training and incentivizing the community to embrace a new paradigm. So next. Then in physical oceanography, there's been quite a bit done, ranging from some of the missions. So I'm going to talk less about the missions and more about some of the things really that the program has done, and including the echo modeling effort and the sea level change team. Next. So just a little bit more about how the program has done it with sharing data, sharing knowledge. So you see the PODAC being important in that, the implementation steps about having open science be a scorable metric in proposals, co-developing implementation strategies. And you can see that some things have been accomplished both on the mission side and on the data side, and folks participating. But there's some challenges that got created, and next steps that are not too different from some of the things that we're hearing about, because some of the experiences are common. So next. You can see examples of ECHO as a first cloud-based multi-platform data integration and modeling framework for climate research. So that's gotten a lot of engagement and activity and been very widely used and adopted in the community. Next. So a little bit more ECHO, the advanced data assimilation, machine learning, and it's led to lots of publications. Its use in important efforts, including the IPCC 6th assessment report, and it's open science compliant. Next. So my summary, I apologize for a lot of the words, but I tried to distill some of the things that I saw and the things that I heard in checking with our team. And so I'll quickly walk through some of them. First one is to make sure that scientists' contributions to open source science get appropriate recognition by the agencies and the community. So like the one chart mentioned, perhaps a no index, but getting factored into selections. Guess unless we're doing dual anonymous peer review, then it would be hard to factor into selections. But awards, promotion, all the kinds of things that if people don't get recognition for investing their time in the open source science, that becomes a disincentive to do that. I think as more codes get made available, making sure that it's understood what support from the originators is expected, and how if that's expected, that the resources are available, that's financial and human resources to do that kind of support work, and also making sure that it's really understood what the community should expect or not expect. Because if the idea is that, say, codes are available, people may expect that they're going to, that there's a help desk equivalent. If that's not the case, that needs to be clear to everyone. And if it is, those doing the helping need to be staffed and supported to be able to do that. Mentioned publishing in open journals. If that's more expensive, someone's going to have to pay for that. So if that's in the grants, everyone needs to understand that. And we need to make sure that we don't inadvertently create a dynamic where some people will be very good and proactive about putting their stuff out there, and making sure that others don't sort of sit back, swoop in, try to take advantage of the efforts of others without doing the hard work themselves and putting things back in. So the community, self-policing may be helpful, or just the this idea that you're recognized for what you contribute, and people will want to do that. I think we also need to be sure that the dynamic doesn't just favor the well-supported and well-connected, because if the idea is that by putting stuff out there, and not just the final products, but the steps along the way, that other people may be able to jump in and utilize and add and contribute, that may work great for those that are already well positioned to do that. But if the idea is to bring into the mix and the fold those who have historically been less well connected and engaged, they may not be just ready to jump in just because somebody put something out there. So if you want to make sure that it's not just the well positioned that benefit, then you have to think about how do you help those who are less well positioned benefit from the opportunity that's available to them. I think one also has to think about, are we treating different types of the scientific enterprise endeavor equivalently in terms of openness, or be clear if we're not doing so. So like, we understand there's a lot with algorithms and codes and software, but what about people doing hardware? Are you expecting people who build algorithms and codes and software to be open, but are you expecting the same degree of openness to those who build hardware? Obviously, if there's ITAR considerations, clearly that's going to impact what's open. And finally, be sensitive to the fact that partners, and there could be private sector, it could be international, may have different approaches to sharing information and openness. So, if we're trying to do things with others those who have some different thoughts about that can lead to a disconnect that one has to figure out how to navigate. Does that mean that, if we can't do it the way we want to in terms of openness, that then we're not going to be able to engage with them? Or do we sometimes say, well, if we have to, if we're going to engage with them, and that's something that we consider as a value, does that mean that we may have to back off on openness? Some of these things, may actually have been decided, or it may be pretty well thought out how we're going to deal with them. But I wanted to share sort of the sense of some of the feedback that I was getting, the thoughts that I had, the conversations that I've heard. And there's a bunch of other charts. Those are all backup if you want to see what the other groups put in that I wasn't going to have the time to use. It's there for you, but there I'll stop. Thank you.
Thank you, Jack. Let's see. So that gives us some more time for the working group. Elias, are you ready?
Yeah, sure. We got a lot of questions for this one. There's the first one that Wen Yang has posted in the chat. Are there any restrictions to software release to foreign nationals when we're talking about open source?
This is Kevin. each center or FFRDC has their own software release authority. As we initiate these projects, we need to run the concept for those software packages through those groups, and they will inform us whether or not there are sensitivities related to it. However, historically, kind of the policy has been, or the practice has been, it shall be closed unless you can justify it shall be open. I mean, I think if you look at SPD 41 that Steve Crawford discussed, the policy is now it should be open unless you can justify it should be closed. So typically there won't be any restrictions on things that shouldn't have restrictions, like ITAR or otherwise, like EAR 99. And we're really concentrating this on the development of the scientific products themselves, not necessarily the more sensitive information. Steve, I don't know if you have anything additional.
I'm not sure if Steve was attempting to speak, but the way we interpret that answer is essentially we're going to do the best we can to make everything open source, unless there's something that's determined that it shouldn't be, and that will be done by the specific orgs that own that. Another sort of question from the perspective of the flight projects programs and the different technology programs that we're speaking here. Do you have any specific guidance for the SAWG in terms of sort of pitfalls and risks that we should be mindful of, any programmatic considerations, partnerships, and so forth as well?
Maybe I will just say just a few words. This is something that we already discussed a little bit with Kevin. I think that there is some flows that probably needs to happen between technologies and technology projects and their transition and infusion into other projects. So this is something that maybe we will have to talk more about and see which type of framework or test beds or something like that needs to be put together so that this project do not reach an end without being integrated in some manner.
Okay, so the sort of recommendations, maybe keep an eye on that infusion strategies and not necessarily count that everything that's being done under these technology things will work their way into the missions. Anybody else have thoughts from like the project and the missions point of view?
One other thing is that we are doing we have a workshop, I think, on the 8th for some frameworks, and we might invite some of the group here to attend that. That'll be the 8th of November. Sorry, didn't mean to cut you off.
I was going to expand it to the flight projects folks as well and see if they had some comments and some guidance for the SAWG.
I mean, honestly, I don't have experience with this, so I'm not sure I have anything useful to add beyond what Kevin would tell you. So I'm the answer, no, I don't have something.
Okay. So here's a specific question for you, Kathleen. You sort of spoke about the requirements, and so beyond the changes in requirements, how open do you feel that the ESO projects are in advancing the objectives that we're asked to do here? Right, and is the participation of the folks that you saw in the SAWG from those different missions, is that sufficient, or does somebody else need to be a part of this to ensure that we can advance and make a successful recommendation?
No, so I think, having the missions involved at the outset is the right thing. And the other question I've seen somewhere in the discussion about this event was, well, should there be someone within flight who's the belly button? And the answer is really no. There's not a single, right? So we have, the way we're organized, we have program executives at headquarters, but our program executives do a really good job of maintaining an open dialogue with the missions who are here. So I would expect that they would get involved on an as-needed basis, but this is, really about the missions formulating the right plan here. So I think you have the right people, to be honest.
Okay, thank you. Andrew Michaelis, you had a question as well that you posted here.
Oh yeah, hi. Benjamin, can you speak to the economics of NASA running some of these ACFs, for open science? Would an ACF be something that NASA would consider running and paying for, or would NASA create some sort of reference system and let others deploy that and run and pay? And then, how would NASA decide resource allocation for users using an ACF? And then,
Sure. Well, I can make some speculations. I'm coming at this from the technology side, so that's about the development. So some of those questions are actually would be more on the operations side. So maybe some of the other folks on this call would be able to answer that a little bit more directly. But yeah, essentially the main things are having the cloud resources in order to host those and put those up, and as long as those are within scope, then I think that would be a reasonable kind of thing. And I don't know, some of the ACF technology has already been infused into things like the sea level rise portal and similar kinds of system. So I don't know, maybe Michelle or some of the other people online here could speak more to the, how those kinds of costs and economics work out.
Thank you. One quick follow-up question, and this is kind of for anybody then. So is there any way for NASA to sort of recoup costs for running any of these ACFs? So example would be not just NASA, your project going out and requesting, I need, X dollars this year to run this framework. Can NASA accept money? Is there a mechanism for that available? I'm just curious. It helps self-support it.
So here, I'll talk a little bit about this. I think we have kind of to come up with a level of service type of construct related to use and analysis, use of analytic platforms and things like that, right? Certainly there are some services that are provided to users today that allow for some basic types of analysis or visualization capabilities, which are provided at no cost to users. We wouldn't imagine that would change in the future. I think, one of the benefits of doing the work that we're doing to make our capabilities open, looking at some of the things that ESTO has presented here today in terms of those analytic frameworks, looking at things like ECHO or the MAP project or sea level change or a variety of other kind of analytic workbench types of things. As we get into those high volume processing capabilities, we need ways to economically support them. So people that are funded to do research will likely have the funding or the credits or what have you to purchase the correct processing power to do that work. However, the technologies that we're using, since they are open, since they are often very transportable, and since the data is in these publicly accessible locations on commercial clouds, which minimize the need for users to do kind of the dirty work of data management, they can take those notebooks or virtual machine or whatever, and run them themselves using their own funding. So I would envision that we're going to allow some level of service, which is free to everyone. But as we become more complex or larger in size, we'll use our typical funding mechanisms to support the cost to do that work. Or if external people want to do it, they can do it themselves. Now, I think there's one really critical component to this, and this was in Jack's set of slides, which is, hey, what about the people that haven't historically been able to do this type of activity because they haven't been trained that way, they don't have access to the necessary tools, or their institutions or infrastructure isn't set up to deal with it. I think that, when I talked about that transform to open science activity earlier, that's exactly what that activity is meant to do. Right, it's to really give people the tools and to really target communities that haven't traditionally used this, and provide funding to them to do some of that analytic work, to let them use these products that we make openly available for their particular needs.
Thank you.
Just to follow on what you just said, Kevin, in terms of the people, what direction would you have for the SAWG in terms of considering that as one of the criteria for this study? How should we take that into account and ensure that we're making sure that perspective is included here?
The people being the people that we want to be able to use the analytics frameworks, or something else?
The people that we're expecting to be participating in, the ones who are advancing the idea of open science, right? Whether that's in one perspective in terms of the mission or the science side of the analysis, sort of the whole people side of things.
So I think you should really have that conversation with our TOPS group. So Shell Gentleman or Yvonne Ivy would be good people to bring in, because they're thinking about this pretty heavily too, right? I don't think that the SAWG has to solve all the problems for open source science. But how you bring it, like it may be applicable to say, hey, how would we bring in a community contributed algorithm, for instance? But it might not be applicable to say, hey, how do we solve reaching into communities that we haven't ever reached into before, unless you think that that's part of it.
So the way I'll take that is we should make sure that we include that as a criteria that we're evaluating. If, for example, if some architecture is not going to enable that and not feed into that sort of perspective, that may not be a desirable architecture that we want to come towards. Okay.
Yeah, absolutely. Yeah, like we're not trying to be exclusive, right? So I don't know if anybody else from headquarters has any opinions on that one.
There's one more directed question for Ben. In terms of some of the technologies that you showed here and you guys presented as part of the program, how do you see that infusion happening now from the technology side and some of the things that are demonstrating into the missions? And also, what is sort of the scope? Because as you know, the scope of this study is to really concentrate on the data processing system. We do have some fuzziness that we discussed about interacting with the DAC side, but where do you see some of these initiatives like the ACF and the multi-cloud? Is it sort of across both the SDS and the DAC, or is it sort of maybe one is more aligned to the other?
Yeah, so yeah, I think there are a number of places where the ACF technologies could be infused, or we could look at places for further development or pilots, or studies, things like that. So I think there are some activities that are already happening, like, for example, the work with image spec on sisters. For other technologies, I think we could look at what are the what are the right opportunities that that fit with the what the ESO goals are, and what kind of infusion or pilot activities we might be able to stand up to explore those further. I don't know, Jacqueline, do you want to make any further comments there?
Yeah, I just wanted to add one thing is that up to now, the technology infusion or transition from AIST to other programs has been a little bit done in an ad hoc fashion. And it was just the opportunity and which projects the PIs usually were exposed to. What we are trying to do in the new AIST 21 solicitation, which is currently on the street, is to request optional third year where we would look specifically at this type of potential transition or infusion, and we would be willing, as from an AIST point of view, to fund this third year, but only with the condition that there is an interest from a specific program or project or mission that would be interested in using this particular technology. So we wouldn't want to fund this extra third year if there is no interest after the first 2 years of development, but only if there is a strong potential for transition.
Yeah, and one other thing I wanted to point out is because the AIST requires open source. So a number of these projects have already been released open source or will be released open source, and that's also another opportunity for collaboration, because you can just pick up these these open source products, and if they're integrate them into things that are being done within ESO. It's an opportunity to look at it and give it a test drive, things like that. So that's just another avenue that would facilitate that transition.
And I might just add a couple more things to this. I think that those are all really good points. But in terms of the infusion question, right, the data system program has this access program as well. And so, I know Andy Mitchell is one of the people that you're working with here. You should talk to his group about what we've been trying to do with the Access project, which is we basically have quarterly meetings with the operations folks and the Access projects to see where we can potentially make those infusion points happen, because we typically were doing it at the very end and it never really worked well. So we might need to have those types of conversations. Anyhow, I'll talk to them about that. There were some other kind of fundamental questions too, right? Which was, hey, what about cloud, multi-cloud, and not necessarily the software that makes multi-cloud work, but what NASA provisions for cloud environments, and how many of those do we really need? There is going to be a study, or not really a study, there's going to be an activity related to that that should be initiated in the next maybe month or so, that SMD is going to be working with Goddard on. There's another question, which is then, if we do have a more streamlined approach to provisioning cloud and the necessary kind of services that span those environments, in, let's say, low and moderate systems, how would that work with things like high-end computing or scientific computing? And that will be another targeted type of activity over the next year. So, looking at the platforms is one big portion of it. Looking at the provision of commercial environments is another of it, because there are a lot of procedures and rules and if you think software release is complicated, just try to get into procurement of these cloud environments and security related to that. That gets equally, and billing for it is very complicated. So there are some things that we're going to be doing, potentially either from headquarters or from one of the centers related to these, that will be available to things like ESA missions. And you'll have that information hopefully in the summertime.
Hi, everyone. We're overdue for a break, Elias. So I'm going to ask the working group. We just want to give the participants a break so we can start
Okay,
again.
sounds good. If we have any further questions, we'll put them in the chat.
Thank you. Good afternoon, everyone. And we're going to get ready to start with our next speaker. Nancy, are you there? Oh, I'm sorry, not Nancy. Is it Sundar? Okay, I believe.
Yeah, I'm here.
Okay, perfect. We can hear you. Please go ahead.
You want me to jump ahead of Nancy?
Originally, I was supposed to go next, but I guess it doesn't matter.
Which works, either one. I just saw, I was going by the agenda, but I saw Sundar's presentation pop up first.
Oh, okay. All right. I guess I will start. Yeah. So we will talk about the high-end computing programs perspective. Sorry, Nancy, that I jump ahead of you. Next chart. Okay. So the program scope, high-end computing really really is a kind of a infrastructure program. We sustain the most advanced cyber infrastructure, computing, storage, and networking. So we have supercomputing centers at NASA that provide large-scale computing resources to mainly computational modeling modeling and simulation projects. And this kind of infrastructure is somewhat specialized compared to the data processing cluster. We have additional layer of interconnect, the network between the computational nodes, so we can orchestrate the coordinated workload. So if you have any kind of work needs to be using multi-node system and needs to orchestrate the accomplished of a aggregated task carefully. This is the kind of infrastructure that's needed. As I said, we mostly support modeling and simulation, and of course we need data to compare to models and to verify and validate our simulations. As you can imagine, we process a lot of we do a lot of simulation, and we have multi-nodes. It can be very easily hundreds and thousands of nodes. So we are grabbing resource around in this big cluster, and there are some efficiencies waiting for 1,000 core 1,000 nodes to be available. We have to grab those nodes, and those nodes are sitting there idle. So we often fill the gaps when those nodes are idle. We can fill with single processor data processing jobs, and those are kind of filling the gap. And when I need it, I can immediately turn it off, and that's how we increase the efficiency of the system. Okay, so so in a sense that even though data processing workload is not optimal for our cluster, we do have a lot of projects that will do the data processing, kind of a workload and very quickly. Next chart. So we previously funded a bunch of projects. We are trying to keep at the leading edge of the technology development, and we have been embracing open science, open source for quite some time. Jack talked about the CMAC solicitation. We required Apache license back then. We did learn something during that time, and we encountered some of the resistance from NASA centers and PIs. We have some kind of a challenge that's being discussed right before the break. They are legal and intellectual property kind of a consideration in some of the software license issues that we need to work out continuously. And also there's a culture issue, competition among the NASA centers, has prevented the sharing. So I think open science policy that SMD put together really encourage us to break down those walls and to really collaborate with other people. So that's a very encouraging thing. Next chart. Okay, so with respect to mission data processing, I talked about high-end computing is really currently not part of the mission data processing systems, but we did support those data processing jobs, and we find out reprocessing is a kind of a sweet spot. When the missions collect enough data, and often they need missions need to reprocess the data, and we can do it quickly if we reserve the time, reserve the resource, plan ahead, and of course we need to have use open source principle, right? The software needs to be ported to high-end computing, and perhaps the group processing the data may not be the same PI developed the algorithm before, right? So those open source really encourage us to move in this direction. And the vision, of course, I think we high-end computing will become part of the mission data processing system, especially for data reprocessing. This is a kind of a workload that we I think will benefit both programs. Next chart. Okay, so this is a prioritized list that I think that we need to pay attention and we need to tackle. From the get-go, I think the cybersecurity is a kind of a challenge that we really need to, from the get-go, think about cybersecurity and work with cybersecurity people to implement any kind of open source, open science kind of architecture. We shall allow collaboration. It's the nature of science. We do a lot of collaboration, and we need to support open science. We shall support science missions procurement. This is really talking about the grants and contract. Those policy, procurement policy, and need to support those different procurement vehicles. I'm very concerned about the hyperscalable. We need this architecture needs to be hyperscalable. Scaling and changing culture is a strategy that's a scale project, right? So we need as many PIs, as many projects to do open science. Without this scale, we really just have hobby, right? So we need to quickly scale to the larger community. without the scaling, that the project will die prematurely. Okay, and science mission, will include both on-premise and in the cloud capabilities, and we need to think about this both in the cloud and on-premise architecture. And we need those algorithms, tools, software, and data all documented well to encourage, to enable searching and reuse. So next chart. Okay, this is a incomplete wish list. Needs to be reusable, reconfigurable, searchable, everything. So that's it.
Thank you, Sundar. Let's bring charts up for Nancy. Thank you. Nancy, could you unmute and make sure we can hear you?
Can you hear me?
Yes, thank you.
Great.
Go ahead.
Okay, go ahead. Next slide, please. And I should just say I'm doing this on behalf of Lawrence, who is having surgery today. So just a quick overview of applied sciences in case you're not that familiar with it. This is our vision, where a world where earth science data and knowledge routinely guide decisions at all levels of society, and people want more. So I think that vision certainly can be enabled by open source science. So we're excited to think about the possibilities as this moves forward. And you can just see that we're really focused on the people using our information for better decisions and actions. And of course, we make financial and programmatic investments to create new creative solutions and lower the technical institutional barriers of using the earth science information. So hopefully open source science will help us do that as well. Next slide. We have a lot of partnerships, as I'm sure many of you do as well. It really helps us get further with our resources. And so we just want to make the point that thinking about partnerships in this effort as you go forward is worth it, to think about how you enable partners to be able to access our information. Next slide. So within applied sciences, we have a lot of work going on in innovative and practical applications in water resources, disasters, health and air quality, the different thematic areas that we have. And then we have capacity building, which is my program, where we really work both in the United States and around the world to build the skills to use our Earth observation information for better decisions and actions. And then finally, we do interact with mission planning. And as you are working on this data system for Phase B, we will look forward to working alongside you. Next slide. So real quickly about applications, what do we do in that line of business? There, we do a lot of ROSES solicitations with individual project grants. And then we have some longer term efforts. The Western Water Applications Office run out of JPL, the NASA Harvest Agriculture Consortium at University of Maryland. Both are focused on reaching across the world and really a focus in the United States too, with those particular thematic efforts in mind, and are also experimenting with different ways to work together with users through a consortium approach and through the really great engagement with the Western water issues that we have right now. And then we have problem-solving teams. So the Health and Air Quality Applied Science team, they have tiger teams that address specific targeted issues. So all of these are potential users for open source science. And so it's really important to think through how users that are not pure scientists, that are applying that science for better decision and actions, can be enabling and using this open source science approach. Next slide. So the capacity building program includes our training program called RSET, run out of Goddard Space Flight Center, where we offer mainly these days online training. In the old days, pre-pandemic, we would also do hands-on training. We also have Develop, which is a feasibility project program where 10-week feasibility projects are done by participants with users to basically grapple with how you use Earth observation information to address their particular issue. And then we have Severe, which is an international development program jointly funded between our U.S. Agency for International Development and NASA, where we work in more than 50 countries in Asia, Africa, and Latin America. in very deep engagement, several year. Actually, we've had relationships with our hub institutions, multinational institutions for Severe's up to 16 years now. So again, thinking about open source science, how does it apply, is something important for us to be thinking about ourselves, and how do we get ahead. And so as we're doing training, how does our trainings, which are really thematic and focus on particular decisions, how do they relate to anything that is being planned, for example, with the summer schools coming up? Next slide. This is the other part, and honestly, when Lawrence asked me to do this, I'm least involved in the mission planning support, but I think it's closest to the conversation that we're having here today. And so it really is about bringing user perspectives to the table as early as possible in the mission design cycle, and getting users ready through the early adopter programs. And then, of course, supporting initial uses of the mission data. So I think that this is where probably there's the deepest engagement as the study team moves forward. Next slide. So we were given a template and questions, and so we'll see how well we did to answer some of your questions anyhow. So the question is, what is our vision for open science from an applied sciences perspective? And so for us, we really hope that open source science will amplify our applications development and scaling. So if you have an initial good idea, how can you then scale that from one city to all the cities in the world? How can you scale it from one nation to all the nations in the world? Not an easy problem, but important to think through. And I can tell you that Thomas Zurbuchen from our SMD-AA is always asking us how to do more in that regard. So how can open source science help us with that? We also should explore opportunities with early adopters on how to get them to use open source science so that others can build on their results. And then for sure, Develop is already engaged with various innovative data processing approaches. They're doing software carpenter training of these 18 and up participants who are mainly in university, but not always. There's transitioning professionals as well. And then for Severe, we do have open source science elements as they were defined when we were writing our solicitation last fall in our current open solicitation. So how you do open source science globally, that's a big question, right? So it's one thing to have resources here in the United States, and you'll see me talking about equitable access as a barrier, but now you go internationally, how you do that. I invite you, and I hope you will think through that. I was glad to hear that you're working the software approval process. Our developed projects are 10 weeks long. The software approval process often takes much longer than that. So it makes it really hard for us to meet our partner needs with the current software approval process. So I'm hoping that you'll be able to figure out how to make that more efficient. And then I will hit again on the equitable access. We within SMD and Earth Science Division and Applied Sciences are all working very, very hard on thinking about diversity, equity, inclusion, accessibility, and how we become a more inclusive place. And Kevin and team have heard me fret about as we put together high-tech solutions that require resources for people to have access, I don't want us to create new barriers to access because we're expecting the MSI's universities to have assets that perhaps they don't have. And so how do we think through that from an equity point of view? That's true also internationally. I would say that, that the cloud providers, the top 2 are US, the third is Chinese, last I looked. I know that's a dynamic environment itself, but how do you equitably use cloud in a way that allows people around the world to use it, including their intellectual property, and their proprietary information, which they're reticent to do. Next slide. So, vision for mission data processing. In your basic statement of purpose at the very beginning, you were missing applications, developers, and decision makers. I plead you to add that not only open science and earth system science. And I know science can include applications, but I really do think it's different working with applications developers and decision makers, and we need to provide for that now. We really should support early adopters alongside the efforts of the DACs to work with and support mission science teams. And as the efforts begin, developing end user tools in collaboration with the community. How we do that, that's something that obviously needs to be thought through. And then for us, you know, efficient mission data processing systems are important, particularly in the disasters world. Obviously, low latency data is really important to us. And so thinking through that timescales aspect is important. There's a report out there that I am going to recommend that the SAWG look at, where we evaluated the early adopter programs to date and what we learned from that. So these are just a couple of those lessons that I summarized here on the slide. And so early adopters programs have been successful. You can see that we've brought new users, we've engaged new stakeholders, we've strengthened the engagement. We didn't have as many decision maker engagement. It was more the scientific researchers. And so how do we do that? Get those folks to care about simulated data and to engage with them in a way that it's useful to them. And so, so really it's a question about how these data systems can enable better early adopter integration. Another cultural barrier, I would say, is the science teams are used to focusing on science, which is really important. But how they then interact with applied scientists and with early adopters who are more on the decision side, culturally, that's a challenge. And since you're breaking all the cultures of science, as you're asking everybody to make everything open before they put their paper out, let's just think about how we can break down those barriers between really the science research and the early adopters. Next slide, please. So we were asked to say what we would suggest for guidance. And so, so here's a couple of things that we came up with. First, consider holistically integration. The rest of the world does not talk about missions or instruments. And our whole organization and architecture around instruments and missions is very circuitous way for a decision maker to find the right information. So how can you holistically integrate the information for societal benefit and across the different satellites within the Earth System Observatory and beyond, including ESA data and other satellite data, and consider what decision makers need and provide appropriate end user tools for them. And then it's really important to enable co-development approaches, which means that you are doing something together alongside with this decision maker, analyst, and scientist team. We have a fantastic model doing that, several different models. Severe does it very well. The HACAS, the Tiger teams do it. We do it with develop as well. So how do you allow that alongside development is really important. Equal respect, it's part of the inclusion as well. And then recommendations for the steering committee are to review this early adopter program assessment report, which we can get to you if you don't have access. And then also consider the applied user perspective, and that their priority is how to bring all this really too much numbers of data sets, tools to bear to their decision. So there's really this need to be able to say fit for use of that information. Where is it best used, and actually when it's not well used, so that users can have a better chance to actually know the right things to pick up. They don't think by instrument, they don't think by mission, they don't think by particular model. They want to go across the discipline area, not only NASA data, and across time and across spatial scale. I think that's my last slide.
Thanks, Nancy.
Sure.
And I will turn things over to Elias and the working group.
Thank you, Karen. We do have a couple of questions. Let's see here. Was it Andrew that had the first question?
Yeah, this is for Sundar. A quick question. So what level of interest is there at the HQ level to better connect the HPC and cloud environments at the network infrastructure layers? So like direct connect, better, more peering, increased bandwidth capabilities, lower latency, and things like that. The reason why I'm interested is because obviously a lot of things are impacted by that network layer. So, I mean, is just kind of
It's certainly something that we are very interested in. I think at Ames there's already work that moving workload from HECC to the cloud, right? And we need high-speed network now in order to move some of the workload. A lot of the work needs data to go with it, right? So the work package includes the data that is now. So we need to have a high-speed network to connect to the cloud. I don't know if that's what you are asking.
yeah,
also
kind
we
of.
need software also, software to manage that kind of connection.
And then there's, funding levels are reasonable currently for that type of work, or could it be better? I'm just curious. It's kind of an aside, but
Well, that needs to be discussed, right?
sure.
So we have a network group, and but we kind of do away from developing our in-house software. I think collaboration with other agencies, and I think with DOE is something that's of interest, and we have a lot of kind of an inquiry or discussion with Argonne, with what's his name? He came to our data and computing working group meeting workshop a year or 2 years ago. Yeah. Anyway, the Globus guy.
Oh, Globus, yeah.
Yeah.
Is it Ian Foster?
Ian Foster, yeah.
Okay,
Ian Foster.
Okay, thank you.
You're welcome.
Hey, Hook, I think you had a question as well.
Yeah, actually, it's quite similar to Andrew's question that Sangdar just asked, but it's a little bit more broader, or at least from a NASA enterprise perspective and expectations for the ESO era. Right now, NASA is growing a data lake in the Amazon Oregon region, whereas NASA high-end computing is outside of that. And I think Sangdar just mentioned about some of the ongoing work to kind of better connect and interconnect the two. But is there any other general guidance more at the NASA enterprise level in terms of certain areas that are more that we should be looking to, or are there any restrictions, or maybe if there are no restrictions in our considerations, is there any general guidance with that regard?
Yeah, I would say stay tuned. This is an area many of us has a similar concern, right? We are moving into the cloud, and the cloud itself is not, east and west, and it's not homogeneous, right? A different vendor has different location in cloud, and I think Kevin talked about a kind of a study, architecture study that we need to need to think about, and this is in the near future.
Should we go to the next question? Sean, I believe you had a question here.
Yeah, this question would be more for Nancy. I just want to say thank you for bringing up your point about about the end user perspective and the application developer perspective. But I guess this is more phrased for Nancy and Kevin overall from a responsibilities perspective. If we're working, or I guess whose responsibility is it to interact with these application developers and decision makers who will be building on the end delivery formats from these systems? So when we're structuring delivery formats and structures for end user applications, is that something that this architecture working group should be focused on, or is that the responsibility of the DACs to interact with those groups and kind of decide what archival format structures and delivery structures we should be looking at?
I think you need Kevin to answer that one.
Maybe he's not on anymore.
Yeah, he might not be on.
Yeah, Kate, that'd be great.
Let me see if I can unmute. Sean, could you make sure we capture that? Could you, if somebody capture that, we'll make sure we get that to Kevin.
Yeah, if we could unmute them, that would be.
Yeah, I think Katie can probably respond as well.
Great, thank you.
Hey, can you guys hear me now?
I can.
Oh, okay, good. I couldn't unmute myself either. So, you know, I think that there are a couple of things that we need to address. You know, Jack brought up some questions about like how do we there are going to be additional requirements to interact with all sorts of user communities, and whether or not they're the applied users or they're the scientific users or commercial users or what have you, right? You know, I think we're kind of really, you know, looking at how we might be able to pivot the DACs to do some of that work, to take some of that load off of groups, and that's kind of one of the reasons why we want to assign them that position a lot earlier. Now, in terms of then how do we, you know, reach out to those specific communities, whether, you know, and you know, science, applied science, and commercial are just some of them. You know, I think the best way to do that is for kind of the experts in those fields to do it, but we need to then translate that back into tools that can be integrated, right? We were having that conversation earlier about like analytic frameworks and how do we bring those tools in? I think this is kind of that same discussion. How do we bring tools that are specific for these communities, whether they be the formats or you know, maybe, you know, merge data products? How do we do that? And I think it's really that collaboration between the early adopters program and the DACs and the mission science teams, as well as if there are interdisciplinary science teams or applied science teams that work together there. We all have that desire, and you know, it takes a bit more communication. And hopefully by starting this so early in the process, you know, we can start to build those relationships much earlier. I think it's also good to have, you know, a center of gravity for some of these products, which is why, you know, beginning to build the communities around kind of single points for data are really helpful. You know, down the line. So in terms of this study, I think, you know, understanding how you bring in new capabilities is really important. What types of interfaces or touch points we need with, you know, early adopters programs or the applied science users or the science groups or the training or capacity building groups is critical because we're not doing all of these things in isolation, right? So I don't think you know, that's part of your job is to figure out what those interfaces are and how we incorporate them back into these specific mission processing goals.
So now
Our next question was from Christopher. Can we get one more? Christopher Engerbertson.
Oh, Elias, that wasn't my question. I think that was somebody else's.
Okay, let me go ahead and ask that. So this is a question for Nancy. Can you please comment on the role that capacity building can play to break down the data access and data usage barriers in this era of OSS?
Sure. I think that the interesting thing to think about, which I haven't completed my thinking, is what TOPS is planning to do for building skills versus what we already do within my own program. So where do you draw the line between building skills on open data principles versus where do you focus thematically with particular users to address a problem, and then by the way you're using open science. So I think that methodology is probably a good conversation for forward work with the TOPS team to think through that further. I do think, if you look at the different kinds of capacity development within my program, RSET's great because it has global reach, literally, and we have good brand recognition as well, NASA and RSET. So we reach a lot of people through RSET. It's a great channel. Those people that participate are roughly science, but also in the applied side. So it is a blended community that we attract. But we don't tend to work on, the principles of open science. I know DACs have their own training programs and ways of approaching training. So the question, I guess, is, how do you best meet users' needs? And I think that's still forward work. I mean, if I take develop, it's a 10-week program. We were doing a 3-week software carpentry program as part of that. They've now tried to figure out how to streamline it because that was too much of our develop team program. But in fact, they were doing that. They realized they needed to teach the participants enough software skills so that they could do the work better. So I could imagine something like that where we would hybridize in some open source science principles as part of it. But I welcome everybody else's ideas too.
Thank you. Hey, Karen, are we running out of time here?
No. Just for folks that are participating, obviously, we are in the open discussion. If there aren't any other questions from the working group, we would like to open this up for the participants to ask questions, but I would also extend time for any of the speakers. If you have any final comments, please go ahead. If not, I will have this be the open discussion part for any of the participants to ask questions.
Okay, let me at least first ask the rest of the SAWG here if they had any more questions beyond the ones that were listed here. I guess I don't think so. There were a couple of items that we did want to talk about at the open discussion. We could either start that now or let you open it up first, Karen.
Why don't we start the discussion? Why don't you guys continue? Maybe that will spark some other folks to comment. So please go ahead. Thank you.
Okay. So just sort of from an open discussion point of view, I wanted to give you a little bit into what our just very early thinking is, sort of a vision for this study. Obviously, we've now slowly started. We had a bit of a kickoff meeting with the team. We've now seen and experienced a lot of the inputs that are coming into this workshop, and so obviously we'll have this recording to go back to. The SAWG is going to be working very closely with the steering committee, and so we wanted to sort of understand what is the expectation in terms of how we will conduct the study and how we go over the time period. Obviously, we'll work within ourselves before workshop 2 to figure out what the constraints, requirements, and how we plan to do this study. What's a good way logistically for us to communicate back to this larger stakeholders, right? We really don't want to wait till workshop 2 before we are sort of communicating. Should we sort of have Should we communicate mostly through the steering committee and then they will sort of communicate to the bigger picture? Should we have sort of monthly reporting? Any guidelines or anything like that would be helpful, because we definitely want to make this very collaborative, very inclusive, very open, and sort of do all the things that we're preaching here. Any guidance in terms of how our current thinking is?
Or I guess it sounds like again.
Hold on. Yep. I just got unmuted. So I think the first thing is we should be posting these types of updates and materials. I don't know what the correct cadence would be, but on the website. And I don't know if you want to have some sort of, Q&A or other type of activity. We are still learning how to do this. So I think there's plenty of opportunity for experimentation, and I encourage you to kind of lean forward in how open you're trying to be. And maybe we'll figure out what's right there. So, I think at the minimum, some sort of monthly status would be great. Potentially followed up by some sort of short period for Q&A in an interactive sense, in case people want to jump in or discuss things.
Okay, we'll definitely do that and post, on the website. Are the folks here, like, we've got obviously a lot of perspectives from different program offices and things. Should we try and reach out more pointedly towards you guys, or is sort of that publishing level good enough and we can solicit feedback from you? Any other guidance, from those folks and those perspectives?
So, Elias, this is Andy. Just want to make one comment. We've heard from some of the project people, and we'll hear more about this tomorrow. They're going to be interested to know the approach to doing the trade study. I think you and I have talked about this already as well. I mean, I think as you start developing that technique or the methods you're going to use, I think that will be something we'll need to publish, and I think that should be done perhaps through a telecom meeting, sort of 1 hour session or something. So there's one extra meeting we probably need to tack onto this. And given we're doing that, it might make sense to have a monthly report out, status update or something like that. It could be like a half an hour or so, just to keep everybody in the loop and just keep the conversation alive. But I think we could be open to something like that if that makes sense to everybody.
Okay, sounds good. If there are no further comments on this topic, there was one more thing we wanted to kind of just maybe open up to. And I'd like to hear from the different perspectives, both the study sponsor, the flight projects, the technology and RNA stuff we looked at, the applied sciences. Given that the study's goals, right, it's meeting ESO needs, enabling open science, enabling the Earth system science, and identifying any efficiencies that we're looking at. Maybe just very shortly, what would you say is a successful outcome of this study, and what would you say would be an unsuccessful outcome? Thinking in terms of success criteria.
So I guess I'll start, and then maybe we can get a perspective from Katie and Steve and Jack and whoever else is on from EST leadership. From my perspective, success here really looks like you've done a comprehensive and a fair look at, what are the similarities that we might be able to, collaborate on up front. What are really the unique capabilities that missions need, and what are some of the things that we should do from a fundamental level, whether it be formats or collaboration techniques, that will enable people to do interdisciplinary or multi-mission products with the open science principles embedded. So I think that is what I would say a success would be, is if you kind of looked at the blue sky and said, this is how we would like to see this done. This would make sense in the future. This is inclusive of all of the vision and goals related to what Earth Science Division is all about. I think that would be incredibly useful. I think a failure would be not to take that first order principle type of look at things and assume that just because things are the way they are, that's how they have to stay. This includes things like policies on software release, potentially on attribution or recognition for open science activities, right? And that's not only within NASA, but I would say in the community that we work with. We fund a lot of these activities. I think NASA is in a unique position to change the culture in a lot of ways, because we work from mission formulation through applied science and archival of data, right? And we have a real big opportunity here to change the way that people can access information, which is vital for understanding how the planet works and how we work within the environment of the planet. So if you don't kind of take that step back and look at the first principles, I think that would be a failure. I'll go on mute now.
Anybody else would like to chime in, maybe from the other perspectives, like the flight projects perspective?
Elias, Katie Boggs had to go to another meeting. So
Katie Baines is asking to be unmuted.
Yes, yeah. Katie, are you unmuted?
Oh, yes. Okay, good. I know I'm not a new perspective, although technically Katie Boggs is my manager. But just to add a little bit on to what Kevin had said, I think surveying the future and current processing pipelines across missions and campaigns, and even within other directorates, science directorates at NASA, would be within the sort of purview of the study team, and also to include any commercial or industry sort of open source tools that might be reused in this space. And I would also, so I'm taking a more of a technical bent on Kevin's response, but also looking at ways that there could be seamless migration between a high-end computing environment and a cloud-based environment, which I know that we've seen happen in other places. That would be helpful. And I think just overall looking for opportunities to abstract out undifferentiated heavy lifting, as they say. If there's something that a workflow pipeline that exists that can be a turnkey approach, I'm all for looking at ways to take the burden of technology development, not science development, but technology development, off of the missions, and allow them to focus more on those things. So those are my thoughts.
Thanks, Katie. Maybe from the perspective of technology and RNA, and I'm sorry for lumping all of those together, but how would you describe a successful outcome of this study, or and conversely an unsuccessful outcome from your perspective?
Well, this is Jacqueline. From a technology point of view, I guess that I would say all of the above of what has been said. And what I would like to add is that maybe we might not be able to measure the success right away. The success is going to be measured probably in 5 years from now. But what I would like also to say that the success will be if we can incorporate as much as possible of the community feedback, and not to want to make a pun, but try to keep an open mind for open science, and stay flexible, and maybe have an iterative process, so that we can improve with the new technologies developing very rapidly every day. Make sure that we can integrate these technologies as they develop.
Any other perspectives as to what would be a successful outcome of this study, from your viewpoint?
This is Jack. I'm not sure that I have a great answer for that. Especially given that once you do the study, it's I don't know whether it's like there's not necessarily a control experiment. You do a study because you're looking to do something different, and I think it is important that one recognize that there's two overlapping things that I'm hearing. One is that you're trying to help make sure that I'll call it data environment for the next generation of missions is something that's will not just help each mission achieve its goals, but to be able to support cross mission activities and facilitate interdisciplinary science and all that inherently good work. And then the open science aspect is that we're trying to do it in a way that's not just the way things have been done before, but in ways that will potentially allow others to contribute, potentially those who may not be actually part of the missions, but who may have something to contribute at relatively earlier stages than those who have not been involved in the missions might be able to have done before, or those who, once they sort of get that sense of what's going on inside, that may encourage them to engage in ways that they would not otherwise. So, I think it's important to try to figure out when you're dealing with the general issues, when you're dealing with the open science issues, figure out when you have to deal with them together. But I worry a little bit that if you try to solve all the problems for everything together, you'll get tangled up with the enormity of the situation. So figuring out also how to what you can break up into bite-sized pieces without sacrificing the connectedness and connectivity that you're trying to get. But if you're trying to do one enormous study with everything on the table, that's going to be hard. But you start breaking it up, and that creates some issues. So I think making sure that you've thought about it, understand the impacts of the decisions that you make, for the choices that you're inevitably going to have to make. I guess I have a lot of confidence that you think it through, you'll do a right thing. I say a right thing because I'm not sure there's a single one right thing to call it the right thing. We put that with some good approaches as to how one deals with things. I sort of feel like I'm in a somewhat uncomfortable position of I have a bunch of questions. I don't have that many answers, and for me personally, with a lot of these topics, as things are evolving in the data world, you're getting into areas that I'm just less familiar with. I have to rely on others who are much closer to that, because I'm learning, but my my learning curve is starting from a much deeper abyss than most of you. Remember, I grew up on punch cards. I evolved somewhat after that, but yeah, after all these years of headquarters, anything more than what I can do on my MacBook Pro or my phone is a challenge. So that's all. Wish I could be more helpful.
No, thank you for that perspective, Jack. And maybe lastly, we can hear from the applied sciences point of view of what would be a successful outcome of the study.
Yeah, it's a good question. So one of the things that I was sitting here thinking about, Jack, I also did punch cards. What I was wondering about was really what the scope of work really is. I think one of the questions earlier was around, the open source publications and how that was being handled in this architecture. And I was meant to bring up this Geo Knowledge Hub, which if you don't know about it, that's the Group on Earth Observations Knowledge Hub, which is their approach towards bringing all the resources necessary together to develop an application, including the code, the explanations, the training. Well, we're working to get them to believe that capacity development is important to that. But it also includes the publications. So I think that the architecture is important to think through holistically from the user's perspective. And then your questions earlier around, the role of the DAC and compared to the role of, the mission data systems and the science teams. I mean, that all has to be thought through. And so maybe that's too big of a scope for the SAWG, I don't know. But I do wonder, for me, success would be that you have an architecture that enables the different kinds of uses of the data, right? So that would be enabling the science research and integrated science research, not just instrument by instrument. And something that would enable applications development by theme. They wouldn't have to know which DAC, which I know Earth Data already does, but there's probably more that could be done. And then how you add on the GitHub app interface and how you add on all the documents, and then how do you really make cloud barrier-free, inclusive? I mean, there's some hard decisions. I saw the comment about commercial. Who pays for it all? So I'm rambling to say that I think that the more you can be open in the architecture and able to meet these different needs more easily, the better off. But I'm not being particularly helpful. I think Jack's comment about you can't solve everything is noted, right? So if you get too complicated, then maybe you can't do any of it. My thoughts.
Thank you for that perspective. SAWG members, any other open discussion topics you'd like to bring up? I saw something that somebody has their hand raised. Feel free to speak, please.
Yeah, that's Arlindo da Silva from Goddard. Just want to peg what Gavin was saying in terms of the spirit of open source, and we heard the same from the applied science person about the early engage in the part of the study. I was struck by a slide in the beginning a presentation where he was talking those different sort of stages from instruments to data acquisition, and then with the open science, the sort of the processing on, you get the involvement of the community. But the thing is, if you really want to engage people thoroughly at these early stages, we really have to, it doesn't, the data is not here yet, but you need to inject a healthy amount of simulation of realistic data sets, not only for the bits and bytes for design the data system, but also the simulated data that would allow folks to start thinking about possible applications and, for data simulation, which one would have an impact in modeling and so on and so forth. So if you really want to engage people early, I think that study needs to consider some form of observing system simulation early on. And then that takes us into high-end computing and all of those things. But sort of the integration early on, I think, is really critical.
Thank you for that perspective. Luke, you had your hand up. Luke Dahl. You might be muted. I don't think we can hear you.
Hey, sorry, thank you. Yeah, I think you'd raised this concern already earlier, but I think it'd be interesting to hear how to plan to address the increasing blurriness between the archives and the mission processing system, and as far as understanding the implications, you know, to the science processing system. So I just thought that was something that it'd be interesting to hear more about, and I think you're going to pursue that in the analysis. But I thought if anyone had a comment on where they see that going, I'd be interested in hearing it.
At least that, I don't know if anybody's trying to speak or they're on mute, but the way that I took that for the SAWG was, yes, there is some fuzziness. Feel free to explore that and then kind of see where those boundaries may be. But of course, any further guidance would be helpful. Any other comments?
Also, in the chat, there's also a question about the team, if they're doing a purely technical analysis or are they also considering budget implications?
Is that a question for the SAWG or is that a question for the sponsors?
Could Rama please clarify for the working group or for the speakers your question? If we can unmute.
I can definitely answer it from the SAWG perspective while that answer is being clarified. Yes, we're taking sort of, it's not just a technical set of criteria or constraints or requirements that are driving us, right? We have to look at the requirements of the mission. We have to look at what the program office's desires and goals are. We're looking at, you know, constraints as well, and those constraints may include whatever those cost uppers and things may be, right? So all these things we are, at least at this point, we are considering to take in as criteria for conducting the study, not just technical.
Yeah, and this is Kevin. I have no issue with that. And I think that there will be, you know, depending on the architecture, implications not just for missions, but for kind of EOS DIS, potentially high-end computing, you know. But this is an opportunity. We have, you know, a number of new missions over the course of the next decade. We really need to understand how we evolve.
Yeah, now that I'm unmuted, I just want to make a comment. I think we've gone through some similar studies in the past. In the early days of EOS, there was a lot of pressure from the community for us to go to a decentralized architecture from a centralized design that we used to dream up at that time. And over time, I think we went to a more decentralized architecture. Now that we've got the cloud and data are moving into the cloud, it's tending to be becoming more centralized. So in each case, there is cost implications, which is why I asked that question.
Yeah, and certainly there are cost implications to, you know, moving to these new environments or developing capabilities for the new environments. But similarly, there are cost implications for people that have to do all of the work to acquire data from different locations or merge it in ways that aren't necessarily usable for the particular purpose. So kind of depending on which way you look at cost, you know, you might get slightly different answers. But purely from a data system perspective, I think that that's within the scope of this study.
Thank you.
Okay. Bernie, you had your hand up.
Yes, I'd like to make sure everybody returns to the last slide that Jack Kay projected, where he indicated some barriers to open source science that we should be aware of and focus on overcoming in the study. So I think everybody should study that last slide in Jack Kay's presentation.
Were there any specific things there that you wanted to bring up for discussion here, Bernie?
Yeah, this topic of open source science may raise some eyebrows in the commercial sector where the intellectual property conflicts with open source science, and that has to be carefully considered in pursuing this study. That's the one thought that Jack documented that I think needs some focus from the group.
And this is Andy. One more comment from a response to Rama's question on centralization. I wouldn't say that we are trying to focus this study on centralization. I would point back more to efficiencies and trying to remove redundancies. I know in the early EOS days, it was really centralized. That was the goal here, but I think now we're really looking to reduce some of the duplicative platforms that we have out there. As Katie mentioned there, technology should not be the hurdle for everyone. We should be trying to solve that and not let the science teams be impacted by that. So included in this study, I would say the DAX, EOSDIS, all of that can have recommendations that are also in the study as well. As we're going through this huge evolution on EOSDIS, don't just draw that line on what we consider an SDS or a SIPS. If there are recommendations, they can spill over.
And then Lucia
Thanks,
had a
Andy.
question about how did we overcome the problems caused by centralization, and why would we return to a centralized architecture since it didn't work before? And I think to that question, right, like I don't think that we're advocating for, one monolithic proprietary system to, I guess that is probably on the spectrum of outcomes for this type of study. Is that type of system that was kind of initially used for EOS missions. However, I think that the way that we are approaching it now is substantially different than what we would have been able to do back in the mid 90s. So by making everything open source, by utilizing cloud environments that are available to many people, we can have a lot of people participate in the development and design and implementation and operations of these systems. And what we're trying to do here is really look for those similar activities, kind of like Andy was saying, that makes sense to centralize. For instance, you probably don't want, every organization to have a user registration or metric system, but you may need different formatting options or conversion options or analytical tools for calibration and validation that are specialized to particular instruments or processing environments. But the point is that if you make all of that open, people with the right kind of connections and collaboration capabilities can reuse those things.
So I just wanted to point out that we're coming up to the top of the hour for folks. I hate cutting off a good discussion, but I'd like to ask the working group. You got some great questions in there. Do you want to continue, or are we gonna, how do you want to do this? Because we have participants that are also starting to drop off as well.
Maybe take two more questions.
Take two more questions. Go ahead. There are questions written in the chat.
Right. David says, how would we quantify value added? For instance, at what point of the mission data processing system is most valuable to fully embrace open science principles? How do we quantify return on investment? I think, you know, it's hard to come up with those numbers right now. And I think it was equally as hard to come up with metrics on how valuable open data would have been in the mid-90s before it was really done. However, we do have some corollaries for open science that we can point to, right? So the Human Genome Project is one such area where they did share the software and the code and the results openly and very quickly. And out of that came whole new scientific disciplines. And obviously, you know, the human genome is an incredibly important component to medical research and therapeutics today. The second thing is that, you know, we've seen that too with how quickly things were done with COVID related to, and I think Shell has a lot of these examples related to, you know, the availability of testing sites or vaccines or sharing of different therapeutic capabilities. So I think, you know, ultimately it's to say, once we do have a community that does this and systems available, and we speed up, you know, the number of discoveries that are happening using open science methods, can we increase the participation in the scientific activities from broader communities? And we have a series of key performance indices for TOPS, for instance, related to communities that we're really trying to target, and what we expect to see in growth for those. And I think that those are equally applicable here. So, you know, it's hard to quantify it, but, you know, we do have a lot of evidence that it's worked in other fields. I don't think, though, that we should limit openness to a particular level of products. I think that if we're going to be open and transparent, we should make the systems open and transparent for all of the components. Okay, I see Jeannie put in a comment about ESD applications in independent study on the value of earth science that they might want to make available. I think that must be available somewhere. I'm not sure. We would have to talk to Lawrence or Nancy or Emily.
Yeah, Jeannie, I'm not sure which study you're referring to. Are you referring to the valuables work that's going on? We can follow up offline. Make sure you get the right thing.
Okay.
All right, with that.
Go ahead.
With that, I think you can close the meeting.
Yep, sounds good. So I'd like to thank all the participants who came today and our speakers for your time speaking and providing all the information to the working group. I'd like to remind folks that we do resume tomorrow at 9:20. Please join us because we'll be hearing from specifically the missions, and there'll also be opportunity for folks to continue asking questions. So we want to thank you for your participation today, and we'll see everybody tomorrow. Thank you.
And thank you, Karen.
Yes, thank you, Karen.
You're welcome.
Thanks, Karen.
And again, if you haven't registered, please take a moment to register on the website.